మొన్న చేసిందే అలా ఉంటుంది.
So you enjoyed the field visit, right? Yeah. So yeah, okay. So we will proceed with the today's session. We will continue the things. I think Sridhar is going to talk about more about field visit, and he will wrap up the things related to that one. I am going to explain the further today's class schedule. In that, I think today all you are most of the times you are working related to machine learning algorithms and that concepts. Either and start with this class and then followed by the lab. That's what is our plan today. So now just I will going to introduce like a very simple concept related to machine learning algorithms, and then how that can be applied to some presentation mapping. So we have 2 case studies where we worked actually, so that things we will present. Before that one, I will give a brief like a connected things related to how the machine learning terms can be taken to the flood inundation studies. Okay. So more details anyway, as per this machine learning algorithms is concerned, now you can see it's like a vast domain itself. By itself it is a becoming a very big domain. So most of the connected things you can always lot of sources are there you can get. So I will give only the connected things for us, what is the for this study, what is required, and that to only the brief introduction of those things related to our proposed you can say our presented study only will be explained. Okay. So this is just like a background, and then what is those concepts and how they can really you can use in flood studies, and then we will see some of the case studies. So first of all, what is the overall this machine learning? So many technologies people are speaking nowadays, right? Connected things. So it's like a machine learning of them, so we can take as a subset. Then what is the superset? What is the I can say we can call one concept, then people are so many connected things they are saying. Yeah, so exactly. So everything now they are keeping is a one big bracket, that is like a AI, artificial intelligence. So in that so many things will come. Okay, in that machine learning algorithms is one of the aspect. Okay. So there we can keep everything under the I can say this one where something like any task normally we will perform with some level of we can say the efficiency. We try to give same thing to the I can say some computer to understand and do in a same to bring it to the level where we can work or better than us. That is the main thing. So we have some limitations will be there, right? For example, limitations, what type of limitations we can expect for human being? So we can do compute like by giving some things, but what is the level? We have some level will be there, like we can't do so many competitions in a small time, right? It takes for us, but we know how the things actually. Same thing we can try to computer will give and tell, that means it is like a no limitation of the things like a numbers of things. It can do whatever the level it want. Okay. For example, I think some of you background remote sensing and will classify sometimes image by looking only we can tell, okay, these are the water bodies, these are things by giving some I taught some few classes, and then after giving some images, if I am some interpretation keys, you can start working, right? Very simply you can do that class and we can tell. So that we can do for a small image. So but here the hundreds and thousands of pixels is there, like we are looking for a very large area. It is not a everything we can't do by like human control system, like it's like we can't do. Okay, so pixel level we have to go there, we have to give exact boundary, hundreds and thousands pixels will be there. There you may not able to do, and it is not also worth to by doing ourselves. Lot of we can say other things will come. So whatever you tell to the computer, you give your intelligence to computer, transfer some of things, so that it will train itself, and then later it will do for any complex thing you give, it will work. That's where this things comes into picture. So whatever we do, we try to give with the same level of some intelligence will provide accordingly. It will systems or computational platforms or any connected things, they will work. So here it is like a making like a whatever the complex thing we can able to analyze and we can make it to give the program, but normally it is difficult for us to solve actually. That's where this particular thing comes into picture. Okay. So as I said, like just now I am saying, right, it is a one particular thing, one subset you can say. It's a very big thing now they are talking about, right? In that one subset is our thing. So the machine learning, the concept is goes something like this. So what is the machine learning basic fundamental principle? You can say our fundamental concept. By this time I think you are gone some, you can say studied some of the things, or at least have some basic idea with it. What you may think machine learning means? Okay, then so we can put into very simple terms that will give you like everybody can understand. Okay, yes. So you are saying some classification and then regression, that thing. Tell very simple terms. Hmm? Training, testing to create a model. Okay, that's also, yes, that is one of the thing. Then so exactly you are teaching you can say the thing. So how a machine can exactly do the some process already it is there, it is done previously. Okay. So here the machine learning means what, we are teaching the machine to what to understand some concept. So learning means what? Learning means we have to provide a lot of data, right? Solve of things like if I want to solve some one problem, I have to give an exam, right, to you. At least I ask you to solve some problems in the class, right? So many problems, different type of questions I will give, like this is the way you come we have to solve like this. So like I will give some 100 varieties of questions, means like a similar type of question, definitely the numbers may change. So that all the combination of questions whatever you learned in the class may come and still you can able to solve, right? That is exactly what we will do here. Lot of previous data sets. Okay. So and then how the data exactly, what is the data input you are giving and what is the output data, what we have to get. You will tell to the computer everything. Accordingly, it will train the whatever the you can see the process. So actually, what it will create in the machine learning, it will create its own concept. Like that's what is that exactly called some in the background theory. You can go further. It say like some function or some you can say the coefficients or some regression you are telling like regression equations. So from your past data, okay, and whatever is the input and whatever is the output past, whatever the events occurred. Okay, what is the way you want and what is the input for that you are giving. So everything you will give and you try to make the process. Okay, so then the process is ready, right? Like that in form the equation, simple equation, regression equation, simple model. Okay, simple like a one understanding of the one you can say the one you can say some 2 to 3 you can say the steps of the process. Anything it will be. So that will exactly the later any unknown data you give to that one. So it will try to make you can say work with that same things whatever you previously taught and it will work. So tell me the what is the like a when compared to the human beings and these systems, right? So machine learning you are saying, right, it will work and it's okay. So everything you will tell to computer previous thing, it will do the post means future things, right? But what may be the problem actually? What is the biggest maybe drawback actually? So it will work for anything like that type of things. It will do. Yes or no? What is the biggest you can say the drawback that's why where we have a lot of algorithms, so many concepts and that is go on improving. What may be the problem? One is like a physics, like it is all like a just like a we are telling, so it will understand something. Okay, whenever it comes, it will try to do that one. That's all. It will not understand physics. That is one other thing. Then one more important aspect actually. Decision making, it is making only we are giving data, right, input data, right. So means it will understand the situations which are only related to the whatever you give input. For example, rainfall events only there, you gave all the possible events, okay. But there is some event occurred which is not at all falling into any of these categories which you give as input. So what it will do, it can't able to replicate the whatever the output process. So it is not following any of the things you give. Means what? It is limits to only whatever the training data you are provided. So your training data is not good, for example, or like for example you give all wrong things. For example, for example I will tell, like you want to classify something like a cat and dog, just like a general computer terminology, their subject actually, they will do this type of things. So you give all the wrong images, you want to classify as a cat but you give all the dog images, for example, only few cat images you give, means data itself is wrong, right. So later it is always confused when you are classifying exactly what you are doing. So it will always like I think the images you give, it will confuse and it will not give correct classification, since you are not trained properly in the training itself, means data itself is a not okay. And that too you gave the hundreds of cat varieties will be there, you give only 2 types of things like Indian origin, for example, there are so many will be there, right. it can't able to make that letter since you gave data is very small, but you are asking for so many varieties of, we can say, these things. So that's where the main things are there. Means data limit means like a only particular thing, whatever you try, it may work for that better, but beyond that thing, it may always have some confusion. Okay, and data itself is something wrong means then you can't expect anything machine learning can do the wonder. That's you can't expect, means you can't get a very better classification if giving a wrong training itself. Okay, so to overcome that one, to work on those things and then makes it is evolved like hundreds of algorithms. Okay, so like it's we are failing in one understanding, going for a deep learning, like a learning one level, learning like for example one class I am teaching, right, in between I am giving so many assignments, some 100 assignments starting to end to learn one topic actually. That is what is exactly deep learning. You are go on giving different type of topics actually, understanding the same thing again and again. So after that one you will make it more, you can see a train, right, better. That's exactly the way it is evolved actually. So you can see that's the thing. So here just that's what I am telling. So it is like a where we are failing at the things like it's like deep learning means number of layers of the, you can say, learning process will be there. Normally one thing will be there, like a one training data will be there, it will give output, right, means one kernel function or one in between learning process. But deep learning means like a different like you will keep 3-4 levels in between. Okay, so it is like a something sometimes what you tell is like it is like a learning from mistakes. So like you are provided like just now I saying like a cat and dog example, you are go on giving wrong results, right, it can go on understand, okay, something this person is giving wrong, so it is only cat means it will keep some backup data from this only, and next time we are giving means it is try to improve further and whatever the wrong it is done, so it will make a further classification little better, then further better, like that it will go on learning the, suppose somebody saying, right, your chat GPT you are giving 100 times something wrong question, like at least later it can understand like you are asking something like this. Okay, accordingly it will give whatever the way you are asking. So it will go on, keep the backup data also. That's what is the deep learning will go and try to improve the your final output. So this is the it is doing so many, you can say that's exactly all the, especially the systems which are physical systems, which are already human developed systems are there, some computer based systems, all things it will do better. But our systems, right, lot of what is the main problem with our systems climate and then extremes, all things. So for example just now we are saying so this all cats dog classification you take, there are a lot of well established principles are there, and then there is a lot of classification procedure there we can make. But when come to our extreme events, right, so if you make 100 classes also, there is one more class which really fall into any of these categories, yes or no? So there the main, we can say, challenge lies. So that's where we can go for a n number of algorithms combination, and as somebody like a physics based model plus algorithms, then simply a machine learning will not work. Physics based modeling has some limitations. Combine those things, then they are called as a hybrid models. You can work. Okay, so that's why a deep learning you can make that type of things. So here the main thing is once again so much data is there, right? So we need to have the, you can say, for other day is showing when we are in that inquires, he is showing one image, something he told one example where one ship is just missing actually in the whole ocean, and you want to, or some analysis they did they want to find where that particular ship is there and then what type of container. So you see ocean image they are getting, right, that much bigger, you can see the place, and hundreds and thousands of data is they are getting, right. So in that one simple, you can say how they are finding that particular thing. That's what is the right now this machine learning algorithm do, where we could not do physically in our normal ways, actually conventional ways. Okay, once you could able to make a better algorithm and we could able to train, and then we can give, means you can easily get that type of things with a lot of, we need to have the lot of collateral data, and this is the where this we are very much interested, and we are interested in this machine learning. So conventional way to do means is not so easy to for large areas to work and to find out, to analyze, where this machine learning comes into picture, and then they will help you. So this is of course where this is the place where we are very much, I think some of you already have the interaction with them, you are already in the place, you are working, some concepts you are doing. So really nice to know that from most of you, at least few of you are working different than what we are already trying, actually that's an interesting thing. So here this is what I am told actually, this thing just to make once again to clear understanding, like just now if you see this is like a very big, you can say, the domain. You see lot of things are there involved right in this one. So national you can say the natural learning process, robotics, so perception, reasoning. So they will combine with this one and they will make a big, this all the system actually. In that we are at one place. Okay, this is the exactly the interesting the machine learning. One is called actually the supervised learning, means we will supervise the system. Okay, so you will give a lot of, we can say, options in the training time. So you give all possible cases. Okay, for example, this one only one example is there, like to classify different type of fruits. Okay, so keep all the variations, like for example only 2 fruit varieties you are classifying, for example. So in that all the things you classify and you give actually. Okay, so you see this is the 2 just like example it is given in this one. Okay, so that will give the all those this you are training, right, means it is whenever this case comes it is very clear for the system. Later you give hundreds and thousands of inputs, in that it can able to pick up which is the orange and which is the apple, right. You are giving some image something, it will classify, right. So here that is like a once we are learning supervised learning you taught, then it will go into the prediction stage. So that is our ultimate goal, right, in the machine learning. Normally you will teaching and then later it will work for you. So there you see it is not falling in any of the, like it is like a mixed thing came, right. So it is like a give one type of thing you gave, but you see it is a different, right. So it is falling this one and it is other one is falling like a this one. There the what is the question comes in it then. So you gave one type of all the things, but it came as some question came where it can't, decision is just straightforward. Then what has to done? What has to be done? There comes the decision. So it has to take decide. That's where the normally all algorithms will work, and there a lot of things are there. So clear cut cases are very easy. So when you are classifying also in the image or whatever we are discussing showing later also, but there is a pixel will come or one image will come where you need to take a decision. There really the algorithm goes into the, you can say, different decision making trees. In that lot of weights it will give, and all those things which is going for a more weightage, that decision will be taken. So in this case only it will give like a number of decision trees. So it is like 100 decisions. So like a, for example, you are not able to decide like a one thing, what you will do? They will say something like a voting, right? Sometimes you see like you will give like a whoever is giving more votes actually, we will say that is a final good decision. That may be wrong, but still we will go with that one. That is one type of decision making. Same thing like here also computer will go on that type of options, like it will make a number of choices based on the number of possible cases you trained. All these things it will check, go on check number of trials. Okay, with these things are there, okay, let me classify like this, it will classify. Okay, then you see the unsupervised learning. So it is like a reinforcement. You will tell like in the school, right? So children they will say some letters they will say and they will show image. They will say that whenever this comes, this is the thing. They never see, for example, tiger in a school times we will see, never see, right? They will write in some local language like our language, they will write that tiger, that thing, and they will give the image. That is like a reinforce, that's all. Like there is nothing like a argument or nothing. So we will say means that is like a that thing. Whenever we come, that letters, that thing, image is fixed to our brain. Reinforced learning. So not giving like a number of trials like that and then say this is a tiger like that classification. So this is exactly the thing. So it's unsupervised. There is nothing like a supervised or we are making a number of trials. So it's normally we are giving thing and then we are saying something, and accordingly whenever that particular comes it will classify. So this is the exactly the difference between machine learning, right? You are giving something, you give 1 or 2 levels of, this is the exactly the maybe the function, you are training the system. Like you see the car means like you will give like a 4 wheels will be there, some particular you can say shape will be there, front it will look like that, and then number of seats like this, all like there are number of features will be there, right? You will train all the things and you will tell only one level will be there. Okay, so you will classify whether it is a car or something, yes or no. But you see in the deep learning, right, instead of one kernel you see in between thing, decision making input and one final decision, like in between decision making, right? You see how many levels are there? So in this case 2 levels, right? We can make n levels actually, n level, that is called deep learning. So you will say that the so many questions will come. Somebody will like a car, so like a jeep also looks like a car, for example. That is different all varieties, but we kept so many things. So it will go under process. Why? What is the difference between a jeep, which we can call normally a different thing, and a car actually? So it will make a lot of connections. It will do understand like that type of. You will provide inside like there is a kernel. It will for the thing some of the training thing like a. So what is the difference? Which is when there some of a decision making some issue comes, it will further make it a number of layers. So it will go on understanding. Okay. So that's what exactly the I can say deep learning will takes place. So just like a simple thing. So you are going into number of multiple chances also will give, try to make it better and better. So that what will happen in a hundreds and thousands of things you give also, it will try to make it a better one, your you can say things. Since you are provided a some more you can say levels of you can say the what you can call what are the kernel function, whatever you say, that is called exactly the learning process will make it better through number of levels. Got it? Okay. So here so then normally the you can say the where is this machine learning means somebody every say that I am using machine learning and I am going to use and then this study I can make or not. So like there is a simple like some trivial question is there actually. There machine learning may not be required actually. There is no point in going for a running one very big machine learning algorithm in some place and then to get actually. It's a trivial question and trivial answer. Trivial means what I mean actually. So but there is a question comes where really we need to work actually. That's like exactly the question like other day in course they are posing. Hundreds and thousands of images will be there, number of day images will be there. We need to pinpoint something which not normally conventionally it is very difficult. Or very big image you need to classify, conventionally it is not so easy. Okay, but all cases where we will come into this one. So for that, so this one to work better, you need to have something like a one of course programming methods. We need to have separate type of concept, and of course processing speed. One of the thing like a there you have here all like a training, right? Training and classifying. Okay, you have to train, and later it has to classify from thousands and hundreds of the data sets. So there you need to have the things like for example you give now and it is saying after 1 hour or 2 or 3 hours. So sometimes some decision making you are seeing like a flood, right? Decision making is that time we can't wait. Okay, there the question of processing speed comes into picture. So you are giving some cat image and then asking for so much time means by that time anybody can say, right? So nobody will wait for that one, right? So like for example catching that you can see the images in the when you are passing in the you can say for example railway station like that, right? So it can go on take the decision time. You can't appreciate the benefit of this one actually. That's what is the thing. Of course. So data like for example you are working right now with system, right? But sometimes the classification will not occur with our system. It has to connect to cloud. It has to connect to other place. Where this much you are improving for example this area domain, your thing will work in a much speeder and then where we get a very good results. Where right now for example especially for our climate extreme events we are discussing, right? It's very easy if you are going better into this type of things where you can connect to one program to other systems. Okay, similarly of course. So here the lot of we can say input, right? Training data, right? For example here this drone for example this how it will really improve your classification, especially when come to our examples only like a extreme flood studies, other things. So the main drawback when we study with the flood studies are those things, so lot of validation points. Okay, we are getting very large satellite image, right? Training we are giving at few points, so you can see later when you are seeing case study, you can't really appreciate really suppose some pixel it is really exactly the when boundary comes it is doing a correct classification or not. Even though you are 100 algorithms you say as per the algorithm rule simply it is like a classifying, right? It says like a I classified with 95% accuracy. Does not mean that it is like a 95% times you are done correct actually. It's not like that. So how to check all the things and verify? So for that for example you can able to make this type of technology means lot of validation points you can provide with other day like yesterday some of the field studies are there, right? Field measurements you are trying, right? So with the all things you can provide lot and lot you can see the verification things, then your job will be easy. So like of course once again it is all like everything is connected technologies like all these things put together, then you can say that yes you are working for a one machine learning concepts. So you are working with GI like a Google Earth Engine today, right? So what is the platform where it will work? It is working in your system or it is working in the cloud? Cloud. So it's like you see like sometimes you give command means you have to wait. So later to run this thing. Sometimes you think that that same thing you run in your system it is more easy. Okay, but it is when you go for number of things you work means then you can come to know what is the advantage. Since they will not give you as individual open source user, right? You are they will not give the speed in the cloud. They will not give your time in the cloud. They will give for other people more you can say the access. Okay. So then that is the concept, right? Then the programming language. So already this already most of you know, and then you see one of the very good you can say sources like anything like a one question normally people will ask whether I am very much acquainted with C++, but some people are saying that they are working in Java, can I work or not? So that's not a matter actually. The question is simple here. Any language, for example, C++, you know, but normally that GE, that Google Earth Engine, it will work in the JavaScript. So C++, they are not two different languages from two different things, entirely different. They are not, you can say, coming into one domain. All programming languages, you can say the algorithms, whatever the decision making, whatever the, you can say, how the loop will work, those things are all common. Okay, there are programming languages like how we speak like Indian language, right? Most of the things are common, right? In some aspects. Same thing here also. In so many things they are same actually. That way it is very easy for you to shift from one concept to other concept. You don't need to worry much about those things. Only you worry is like how the, for example, you are no C, what may be the similar things in the Python look like? Like you are calling some input. How you will call in the C++, how there is a variation in the calling in the thing. You need to read a file. How you are reading in the C++ and how you may have differently, they may give some input function, bracket will be there or not, that's the only thing. So second is, like you don't need to worry about the, you can say the different, you can say the, so you can go on shifting the languages, not required actually. You are, for example, you are working with Google Earth Engine, JavaScript will be there, you go with that one, that's a thing. So you are go on shifting between different languages sometimes may not help actually. Sometimes here only thing is, normally we use for our things like especially mapping, satellite images, dealing, it is always better since we have a lot of cloud things are there, Google Earth Engine may work better. Since everything like you can't go on data getting from some place, dumping into your system, there you are doing classification, one more you can say machine learning environment to shift there, work there, once again keeping, it may go on giving some difficulty. So better in that case, do the Google Earth Engine, their only machine learning algorithm platform is there, their only other things will available for you, JavaScript code will be there, you can proceed. Otherwise, you can go something like a Python also. So Python will be like a one more like a same thing like a, you are using the, you can say the, some cloud environment. So where is our Gmail is there, right? So there only we have that, we can say the drive, cloud drive will be there. So there we can make that Python, we can say programming environment. Collab, exactly. That is the place where we can work actually. So GE also like, yeah, that's like a libraries it will call actually. So that's what I'm saying, like nowadays is interoperability is not so difficult. You don't need to much worry about the what you know. Whether you can shift to like you start working in your own environment by bringing all these things to your environment, or otherwise you transfer all your environment to that particular language. No problem. You can do without any difficulty. That's what is the suggestion. That's what we observed also when the students are working number of times. So this is the sum of the, you can say hard, you can say the programming environment where a lot of algorithms are available. This thing like one is like a TensorFlow. Is all like a, it is I think basically the Python related aspect where we can see as I know actually. So it's all like a hard, like a, you can go something data you will give, there is some algorithms available, you can download or they're only available in the system itself if you can, there only you can do, or sometimes you can put into your system, bring it to your environment and then you can work. So like these are all like only meant for machine learning, right, that type of things. But GE is, machine learning is one aspect. It is like an entire environment where you can call these functions, like a, what is the functions are in TensorFlow, we can call there, like that. So there are like algorithms, right, like a machine learning supervised clarification, I'm saying reinforced the deep learning, right. So you can't, there are not simple mathematics, there is a lot of programming code will be there, you can need to transfer those things and you need to work, okay. So same thing like a Keras, this is one more you can say environment where you can, this is like a basically Python based, previously I think that is like a JavaScript based, I think just you can check more details in their website. So these are all like a, you can get lot of things, they are available examples, you can work with these things. There are hard coded machine learning algorithm, you can say sites, environmental environments where you can check really how they will work. So it's like a, where we can see, this is like a, more like a Python related, you can see that these things. Python is one of the things, is basically we have the Python related machine learning thing actually. So then come to the, you can say the, what is our goal actually. So our goal is to see something like a, how really we can put something for our flood studies. So how we can put together some algorithms and see how we can image, we can classify. So it is like a, as like a nowadays like a, most of the you can say applications, as I said to you, like a, so many, our group is right now the students area, there itself there are few people are already working actually like that, so many are working. So here where our conventional things we can't able to understand, we can't able to model, you can't process, always you can look for a this type of machine learning algorithms. Okay, extreme events, we are discussing all the things, right? Any one domain, it is possible to work with a machine learning algorithms. Okay, this is what I am saying. So some of you are saying, right, starting up this session, like a physics plus machine learning will be better always. So only machine learning, sometimes later for a very new problem it may fail. Physics means it will not fail, right? Anyway, whatever the equation, once you know the flow equation is there, normally anytime it will take care. So flow equation is there, and you are training with some wherever the error comes. That is always a better choice. Like that is called hybrid models. That is like nowadays they are taking the momentum. Is people are working with those type of models. Okay. So the goal is something like this, like a longer lead time you have to get. So you have to get a better accuracy. That's what is the main goal. Most of these studies. So here we can do not only like just now I showed one example. I am saying one case. It is not the one case. Like hundreds of cases is possible to our thing. Like a other day, like a Sridhar is showing some of the case like for you, like in the extreme events related to the droughts, right? And heat waves prediction, and like a hydrograph where data is missing, there we have to go on predicting. Land use land cover classification, that is a basic input for the thing. Like hundreds of variations are there, but we will follow one type of concept where we can use this machine learning algorithms. So for that, once again we will see what are the common things. So I think you come across these things, right? Some of you are gone that literature, you are already verifying. So you will see this thing. And so many times wherever the people say like a machine learning means, they will say like a, they will ask first question like whenever reviewer in the paper you are writing also, like you are using which one are feeling better, or why is that only thing going better. Somebody said that is better, like that. These are the normal 4 things we tried. And here one important thing you have to know, it's not 4. How many are there? Anybody can tell? So like so many numbers, like if you say like a gradient boost, they say like a plus, like a things like improved gradient boost tree by so and so, others are like that. So many variations are there. Just like there are some basic type of things which normally so many times people are using for our studies. Like there are some hundreds and variations are there nowadays. But always in the study, like there is nothing like if I say one thing, when you are taking some problem of your area like that thing, you don't think that will only work. That is exactly may not be case actually. For example, I am studying like something I say correct, your case, your data, that may not be a correct one. Okay. So it is always when you are doing machine learning, something you are saying, machine learning is one type of learning technique only, right? It is always say something with a 2 to 3 techniques, then only one. Then your analysis, for example, in a writing a research work, okay, I tried only with a random forest and I find, and then this is the thing means they may not accept. The reviewers or the letter, your thesis, all things. Always you said that okay, this area I tried like some 7-8 algorithms, 4-5 are doing better, in that this is doing better. Then they, okay, this person done lot of insights, so okay, we can accept. That's the way normally it will happen in these cases. Okay. Once again I told like I will not go deep, this itself is a very big thing, like this each one is a very one big technique, like what to give input, how to tune the kernel, and how to get the things beyond our discussion. And then you can always, I said, like a lot of data nowadays available, you can through open source, but I will give a just everything few lines, then we will go with the case study. Okay. So normally, so support vector mission is like it is like a one type of classification only. It is a supervised classification. So it is like all the data whatever you gave, right? You are giving a number of data you will provide, right? So for example, you are given 3 types of classes, like at some training. For example, our satellite image only, you take a simple thing, like a water bodies, and you took the, you can say, some agricultural lands, and something like a built up area. Normal 3 trivial or important classes normally you classified. So like it is like a question is something will arise, right? One pixel in the whole, like you gave a lot of training data, and it is like understood like one pixel comes means what category to put. Okay, it is like 3 baskets are there. So one pixel we have to throw in one of the baskets. So like there are 100 pixels satellite image you will pick up and drop in the box. So in the supervisor this support vector mission, right? So there is a pixel comes, right? It is like between the boxes you will draw the one line, like a middle line, like in between. So like a hyperplane type, that's what they call actually. In the between the 3 boxes you draw hyperplanes like a thing. So for example, there is a one pixel question, like some confusion pixel came. It is like in the it's like 2 boxes are, right, like 2 seats, there is a one in between one seat is there, and you draw one perpendicular line. So some pixel is very close to the one basket, for example. What is the chance that that pixel may go into that basket, like it is throwing to the faraway box, you can throw to the nearest box, right? That's the thing. Means some you can say characteristics or something related to that particular pixel very close to the one basket. You drop in that basket. That's what exactly the very simple. We can say no. We can say without any knowledge, we understand that one means that is the way it will work. So making all the separate boxes and then drawing the perpendicular wherever one pixel question pixel comes, where to put in that one question will come. Accordingly, we will keep. That is exactly the meaning here. So you will make a one boundaries and then we will make that, you can see the boundary like a, you see the, it's like a, you are maximizing the, you can see the things and then accordingly you are keeping into the thing. It is like a maximizing the error means like a minimizing the distance. That is what is the, you can say algorithm. So means you have to put the nearest basket when the question comes. Okay. So then the random forest algorithm will work something, this is what I am, it is something like this. So it said like I just now I said right, you will give a lot of questions and answers you will provide and then you will give into things. Okay. So you are, I said right, it is like a, sometimes it's a trivial, it is classifying. One question comes like a, it is not falling into any of those questions. So you write like a 10 questions you prepared. So 10 answers you know. So the question gave like a combination of those questions. So you have to write like a which answer to write. Okay, then that question will come like a, it will go on make a decision trees. For example, these two things means this is maybe the answer. These two things, this may be the answer. Like that it will go on make a number of, we can say, decision trees. Finally, it will come into the conclusion like a, so many times it may think that like a more approximation is going towards something. Finally, the decision go to that particular thing. Like a 100 decision trees you make. In the 100 decision trees, whatever you are built or whatever you made. So in that so many decision trees it is giving like a, your answer like a says whatever the decision trees you prepared. That so many decision trees is giving one answer. You will go with that answer. You got it? That way the random forest will work. So here, of course, this is what I am saying. Okay. So here similarly it is like a one more cart algorithm. It is like also like a working like it is more like a your you say somebody like a regression algorithm type of thing actually. So where regression means what we will give some training data is there like two levels like one observed data and what is the data you are saying like you are training the thing. So you are making some regression equation for example. So regression equation like here normal regression means you will do normal or mathematics actually. Coefficients some input data you will find out coefficients you will make the equation. Any unknown data you will keep into the thing depending upon the whatever the regression equation you are built. Okay. So in that is the same way actually here also we will make a number of you can say the regression things. Okay. According to that regressions it will take the you can say your value. So fit into one which regression equation accordingly you will classify into that particular thing. That's what is the cart tree. Okay. So it is like a, you see like it is more like a regression thing means this may they may say like a, as a nodes like a, so it is like a recursive understanding of the you can say the one node and the terminal node like that it will go the whole concept. So it is like a, suppose you are missing at some place regression when you are doing right. So it will that will information we can take and then it will take it to the next like a, so it will also provide some like a, you are assessing the quality of that you can say that your decision, that also we can able to assess and that also we can able to keep actually. So in the regression tree what we can do is, so you can give the classification and also the probability of misclassification also we will provide in that particular one. Okay. Same thing it is like a one more you can say thing actually the same. So it is like a, this is I told like a gradient boost tree means it's like a doing the errors and getting the from errors learning to do better. So like a wrong thing means like how much wrong, that way the you can see it's like a sequential of the learning we will make actually you see. So more the things actually, so we will not go on a number of things right, it is like a go on making the your residual errors it will go on reduce and then accordingly will make a better thing. Okay. So as I said to you once again you definitely these 4 are normal user algorithms in addition to so many hundreds of algorithms. You see like a, it's always better whatever the algorithms you are going to use. So the main things you have to remember in the programming thing is what are the input like they are say some kernel function value, some probability value, fitting function like that, so many terminology are there. So you see always they will give all those things normally lot of example data sets are available. First you try with the example data set. So tune like a, what the output they are giving, how they are doing for any unknown things, you see what is the values they are changing. Then you try to apply for the your problem. Otherwise how we will come to know like how your problem it is working or not. since otherwise you tried with some other things. So like that you whatever the you based on the previous literature or other things, you take few algorithms which feels your fitting your study, then work on the examples, then start working on your problem, whatever you are thinking like to solve. Okay. So this is what is the thing like some 2 case studies like we took actually, and nowadays so many examples. For example, Google Earth Engine only you are working. For example, you say like so I want to work with some flood, you can say inundation mapping. Can any have example case of code or whatever things? Means you will get another. So many are available nowadays. Heat waves I am working. So any machine learning them to classify like that. So that time so many things are available like already inbuilt these things. So you can try, you can see. So we will make some of the, you can say our own like a way the how to do this one. We tried actually that we will show you here. Okay, our case. So here, so this is like a, of course these are all general things. Most of the things already happened. We discussed all other things. So the flood inundation map means what? So when flood occurred, normally actually we are seeing right. Somebody asking like a why that you can say some lines are there. Later also they put some poles, or the banks also. Beyond the banks also something say that they are asking like a so flood where to flood you came. They are asking like even they, that flood is come to the village also. Okay, what is the meaning of that one? When you can say something as flood. So yesterday you saw that stretch right. Only water is up to the bank full. Then we can call it as a flood actually. No, so bank full it is like that is the you gave the that particular area to the that river right. Stretch you gave it is flowing full. Okay, that is up to level. It's like a it may be peak discharge, but we can't call that as a flood. When we can call it as a flood? You gave some like you dividing as a what is the water flow area of the river. Beyond that one, like you see that post or like a red post on that post like a triangle they make right. Then onwards it is going away from the higher regions right. So whenever the water recedes and then still further like all those measurement they put the marks right. Then beyond it comes and flowing further on the banks. Then we can start saying as it is a flood. Okay. So why that flood is important? That flood like when we are working with any of the most of the you can say the things. Why flood inundation is important? Flood inundation why we have to study like flood is coming and receding and is going later and then everything become normal right? So many trivial cases we can miss like you can solve like a first important question is flood inundation occurred. Means we need to know immediate thing is we need to know area of inundated area. Why that is required? Normally simple case. Yeah, like a one is like a of course we are doing a some any this is all like a post flood thing actually. So you are classifying in this case in the particular case flood occurred inundation you came to know means later you want to analyze how much is inundated. Like a one is like a damage assessment right, like this much agricultural land is damaged, this much built up land is damaged, accordingly you can pay the compensation right, they will pay right, exactly like this much cropland paddy is damaged like that, yes or no. Other one is like you are analyzed like some hundreds of like some 100 event flood you analyzed like inundation maps, what you will get? Demarcation of risk zone, like you are analyzing some 100 floods, 100 events of that same yesterday we saw that particular thing right, they gave the extreme events they are mentioning right, all the things you analyze the flood inundation area. Like in that you see like a, for example some 50 years recurring flood, how much it is inundated in, 20 years, 10 years, like whether they are matching or not, every year some extra areas coming into flood, like that you will come to know right, that you can demark the flood risk zone or flood inundated you can say the area which comes under the flood hazard. Or you can say flood plain, flood river is there different and flood plain is different right, you can prepare the flood plain mapping, so flood hazard zone mapping, so all the things we can make, accordingly you can classify the vulnerable map like which area is going to vulnerable every year. In a city means you can make this area always going to flood, so you don't go for a very big constructions like that. So this will give lot of you can say answers, that's what I want to tell you here. So here so many you can say this land use planning, all things, this is what I am saying. So with one answer like a one inundation map you prepare means it will give a solution to hundreds of other questions, that's what I want to tell you in this case. Okay, so in this case the question is like a same like a this algorithms we tried actually whatever is available and then it's like a different things. So it's like a sentinel data like other day starting day itself you are tried like sentinel and you are using like a SMAP snap you are using. So that is the where exactly that started actually. So it's like we took a case where the, I can see one area like that is like near to Bhadrachalam, like yesterday we said that Godavari, right? Means it's a tributary to Godavari. If you go further deep inside, go to the further area, there is one region where the Godavari is there. Further you go downstream, there is one region, I think some of the people who are from outside, that is called Bhadrachalam region. I think every year we will follow newspapers or you can see this thing. Every year they say that there is a chance like a flood increasing and this is a temple town is going to submerge some area, like they are go on saying, right? That is exactly the place where we are analyzing actually this case. So you see the normal like one event actually that's taken some from the news this thing articles. So it's like a 16th July 2022 thing. So the most of the you see this is the you see what is this area? Main river, and this is all area coming into the floodplain. This is the inundated. We see it is almost like a coming to the you can say the area like you see this is like a two-story building like this is almost this area. But you see sometimes you see windows you are seeing means it will give so many things actually. So this is the where level of you can see the flooding. Okay. So you can see the you can see that now. So we want the you can see this mapping we can do with this one, right? Like a different data sets we require. So here flood inundation we are not doing means what it is a flood is occurred. Normally flood occurred means it is a precedence. What is the precedence event actually? There is an extreme event will be there like a lot of cloud cover will be there. Then rainfall will occur. Very big rainfall event will occur. Later the event will stop. And normally sometimes even the rainfall is still occurring, flood starts. Otherwise rainfall stops and then this flood event take the momentum, it will start. Okay. So the precedence that event like a we say like a cloud cover I am saying, right? Sometimes cloud cover will continue actually. You can't see that flood is over means everything will over, like rainfall stop means everything will over. Cloud cover still continue. Okay. But we want inundation map. How it is possible? But you want to take the thing, right? That's what is exactly the other day we are starting one discussion we did like NISAR mission or other things like a micro mission, right? So they will provide the data during the cloud cover also. Even rainfall is occurring, clouds are there, full thing, whatever the things, daytime, night time, every time you can take the image. That will help us to answer this type of questions actually. Sentinel one especially the this thing. So this one is required like a Sentinel will give even Sentinel also will give the data like a which is like related to the normal like a visible spectrum, blue, green, red and infrared also. That we can give for of course land is land cover mapping. Even you can use the Landsat or more better satellites. So you remember here normally this micro data we can use for flood inundation mapping. This is for land is land cover mapping. So you say something is inundated, how you can find out, how you can verify? You have to go back to the data before flooding. Means you need to take one image before flooding. You have to classify, then superimpose, then subtract. Then you will get okay. This is the this much agricultural land is submerged. This much what we can call as the city urban submerged like that we can tell. So for that one very good image, high resolution image before flood, one very good image during flooding occurs. During that you can see including all the cloud cover we have to get one thing. So anybody want to do flood inundation mapping, they have to look for these things. During flooding, water level we can know. That's a one question that is important question. Is like a two different questions they are. One is like a flood occurs inundation. The two questions will arise. One is like how much area is flooded. Second question is how much depth of inundation. Like a, for example, just now previous images we saw, right? So the question, for example, this much depth is there. Right? This is like an important question, like a planning evacuation, like a to know who are under more risk actually. Okay. So this question normally you can't directly answer by this person, like this. We can't directly go depth actually. There is some other way you have to do. That is separate itself is a separate study, like where we need to have a digital elevation model. That DEM also like we need to have a high resolution DEM, something like where you have to get for a different like a 5 meter resolution, less than 5 meter. So that DEMs and then you need to correct that DEM with all the local, all the variations. Then you can tell like even depths also. So in the flood inundation mapping, you remember here only you will get the surface area. Depth means you have to superimpose with the DEM. Okay. So for example, 20 meter contour interval is covering your inland area. What is the meaning of that one? There is a one river stream is there. For example, that start with some contour interval of 5. So now you superimpose the flood inundation map. So it is going up to 20 meter contour interval. What is the meaning of that one? 15 meter already is submerged. Anything is there on that level. So it is already 15 meters thing is there already submerged. That type of questions. So but we need to do little different analysis than this thing. So at this case that is there, but we can do, that is a very important thing. Now people are also working on those things also. along with indented area, it is to depth also. Okay. Yeah, DM you can get, that's only I am saying. So that we can do. So, but high resolution DEM, you have to use not like our Ester DEM, those things will not work. You have to go for allows pulsar and Carto DEM with 5-meter resolution, priced one, that is not open source. That type of DEMs you have to use our LiDAR mapping, but so many other things are there. That is a itself is a different thing. So, of course, this is also very important thing. That question comes. So, just now I showed you like this image like to quickly you see here. This is the one you see here, right? You can't call this as a flood, but this is a flood, right? So now when you are masking out, right, otherwise you say something like this much area is submerged, that is not a correct thing. So you have to subtract this from the, when you are mapping like your sentinel data, when you classify, it will give entire water thing as a water pixels as a one thing. So in that we need to subtract the flooded, you can say like a what you call permanent water body. It is already water body. So up to like yesterday we were saying like a bank full, that bank full is already water. Whenever it will comes, it will come. So during complete classification, you need to subtract that one. So that how you can get that things like a, so for that we know how much is the bank, those things for that, right? There is one very important, this is very important actually, when some people who are doing this flood mapping, it is already well available like maps are there, or otherwise you need to prepare. So we need to mask out this permanent water. So once your flood map comes means you subtract first the permanent water bodies, then remaining will become the flood. Okay, this is an important thing when you are doing this type of studies. So this is like a one image. You can see two band. Actually, once again, central means you will give different type of bands. Like that is itself is a once again very important aspect. So many things I am not explaining here, but only thing is like a VV band, like a VH will be there. So combination we can generate like a VV. This is called like a microwave data is available in a different way. Like our regular visual band data means like you will get like a blue, green, red, infrared like that. They will available normally like a band, different polarizations or different bands. So they will provide like a VV, VH like that. Okay. So in this case, this one. So you are seeing not able to see the thing like for example this image before flood and this is like after flood. You see this area like this whatever the dark color is more or not. So you are not able to see, for example, also no problem. We can see here better. Now it is clear. So you see this area very clear, like this area like Godavari wherever I am saying actually it is very clear water bodies, they are all like a blue color the thing. You see during the same day, that event day, you see this is all areas are now become blue color, right? If I am saying subtracting this permanent water body means these are all like every time water is there, okay, it is available up to, even see some of the white patches. They are sandbars within the river, like you see other day like only two sides water is flowing, remaining all dry, right? Same thing like a big islands also form within the river. So those things are all like they may be dry, but during flooding they may flood, but that is not still we call it as a flood. So further other things they are occupying, coming out, and we can say that is a water. You see even these are not floods, right? They are the already water bodies. You see there is water bodies. Any surface area is increasing further means we can call as a flood. Okay, that is important aspect when you are classifying. So these are all like some of things already you tried in the day 1 or day 2 somewhere, like a day 2 snap data, you took some download image and all the things. So some of things you will see today also morning itself they put message, right? You download things and keep ready those things. You keep those data sets. So we will see like some of these things how we will do one by one. I will show you quickly that this one. So first of all you make this pre-process, make it ready, apply algorithms and take out masking out that permanent water and then flood map. So there is one more trivial technique is there. We can do some, this is called Ostu's algorithm, but this will give a very trivial case, like just within few minutes you will get, but it is not so accurate. So see that one, how you can compare actually, compare with validation with some other thing. Then we can make for the all the like whatever the error things you can try. Okay. So this is like a thresholding method is very simple technique actually. So something like an image is there, right? If you are seeing the image, satellite image, different levels of pixels brightness will be there, right? Number, that is called image, you can say the value. So you DN value, exactly, you say that is exact means answer what I am saying. Background will be, everything is a number, digital number, right? So the threshold means you say, like for example, any pixel value more than 150 comes the value, or like when come to flood means it become a more darker, like a less brightness, right? Which is coming 20, 0 to 10 means everything comes, you make it as a flood. it will do like that, and remaining all it will make as a non-flood. But it's like a very, like a question is not so correct, right? Something 9 comes like a brightness, sometimes that is not a flood pixel, that means something else. So it will not give a correct picture. Just like a one go, like a just 1 minute or one thing we can able to do, just like as a one at least idea we will get which may be the possible flood area. That's the thing. Okay. All these things anyway you can, this is like a how to make this permanent water. So the question like this permanent, nowadays you can have satellite systems which can do this one. You see, anything more than 5 months water, whatever says it is take as a permanent water body. Then remaining all it will not take. So that image is already available now. So you can subtract those things actually. So then this is the like a simple things. Now just like a quickly I will go through these images. Like a most I guess is like easily we can understand. So you see the here first one. You see this is like a algorithm, like a threshold before masking means. So everything now this is also flood and this is all like a looks like flood, right? Taking out all those you see in the middle of this river, right? It looks like a empty, right? This is like a non-flood. So these things are only flood. That's like a after making the you can say the masking. So here the A before masking and after masking actually this is the thing. But you see lot of area you are saying flood. That is not a correct. So this is the correct picture. This is like a SVM. Support vector mission means, so you will select physically, these are all the pixels. Whenever you come across these pixels, you classify as a flood. So it will make, you will train like the first algorithm. All possible cases you will train that all the kernel function, everything accordingly. Later it will, you try for few pixels, right? Remaining all it will classify as a two things. Same thing with so random forest. Same thing with you can say the cart. Same thing with other algorithms, whatever the things. So it is like a overall understanding of things. You see, it is doing a lot of flood pixels. It is saying, you see, number itself. You see, any comparison is there between two numbers. It's totally this thing. So it will not give a picture. That you know logically we will not consider. So, but you see, there is a little comparison between these things. This will tell us everything is doing better. But in that better, what is the best to select is the question. This is where we need to do our work. Okay. So this will help us. There is accuracy to calculate like a after classifying the image with already classified pixels. It will give you like a which one is better. So looking like sometimes most times you will see this is better. So you don't confuse with this so much close to 0.9. That does not give you a correct picture. So already you taken some pixel. Already you are training. In that only training it is doing that much pixel. That is not a correct picture actually. But you need to have something like a one more validation. You will see that one. So we need to validate, right? We took a like a, you said like a, we don't have the observed data. That is the main thing here, the problem. Like we can't physically go and see that plexus flood. Like we need to run some drone images like that, then we can get. But in this case, it is already happened flood. We are analyzing now, right? It is already 1 year back. It is occurred. So we need to get some source. They have to provide something like same time. What is the flood inundation map? They may be tried. They may not try machine learning. There's something else they tried. Okay, that we need to show here. No, we need to take that one. Some points, all those points you have to pick some points like this. So 100 points. We took actually 70 points are flooded, 30 points are not flooded. We took from the Bowen image. So that they clearly give the flooded area. So we took the randomly those points across the thing to see whether we are did correct or not. So that's the points along the this thing. So you see, so you see this one like a, there are the you said like a 70 pixels are related to the flood, 30 are non-flood. In this SVM, so you see like a flood, but it is like a, it is also telling 5 pixels which are non-flood also it is saying flood. Similarly this one, so it's a non-flood 14 pixels it is saying as a flood pixel. So no I am sorry actually, so it is here it is like a this thing you see the correct, this is the correct classification, right? Diagonally this one is a wrong classification. Okay, so it is like a 5 by 10. 5 by 10 is like a, that type of you can say the means 5 by 30. But 30 pixels, 5 pixels are wrongly classified. It's like that. So that type of you can say give the actual this one. This is a very important check you need to make. Okay. So that's like a giving the locational accuracy the CC. So this thing normally this most of the studies also we also observe that this is giving better, but don't take as a straight away question. That is like answer. So it all depends on so many other factors. Okay. So then we are supering with the land is land cover. So then you see this one like a how this this each area like a, these are the 3 things we classified, right? We superimpose. Then we'll come to know that how much flooded area comes from vegetation, how much built up land, how much barren land. Okay, that will give the idea. Like this will tell us like out of classified flood pixels, this many area submerged from vegetation, this much from built up, this much from barren. It will give you idea of like how much is damaged. So this is the complete example thing. So I will not like a same second case is there now, it's a time thing like any it is already shared to you in the drive, it is already there. So directly we'll go to the, so this is like a things I will show you the same case for the this thing I will not show right now, we can have a look at those things. I will go to the last thing and conclude within 1 minute actually. So here tried with so many algorithms, it's like a well-established process is there that we tried, and then so one algorithm, this is the main thing I want to tell you at the end. Training is very important thing. So you train number of data sets, backup data set, trying, checking is always make your answer correct. Okay. So validation is taken from second resource we took, but it is always have a field validation with a very good data means yes we can prove that your classification machine learning is doing very good. Okay. So this is all like I said right now sir, like once again this is Sridhar and myself like a same thing, like we work a lot of this thing and then it is published like this thing very work actually good student MTech students if they worked actually. So presentation map for that Bhadrachalam region whatever I showed, this is already is available in the public domain now. So other things also like a lang this is like this is one I told like one explained, there are other ways also we can use machine learning algorithm, that's what I am telling to you. They are also available in public domain, so that we can use like a very machine learning algorithm we can use. There are source web links which are what are the data you given. They are the students I saw right, they are did the things and then the number of time they prove like we can do beyond the doubt this, you do very good exercise, very good work. Okay. So I will immediately at this point I will stop. So give me 2 to 3 minutes, that's all like you can give for the questions. Any questions? Hmm. Hmm. Training data. That is a simple like we have the image, that's what I am telling. We are training right. We know that clearly like we will zoom in like for example in the flood pixel which is there on the I can say like right now we have the before and after flood is there right. One image which is there on the land thing already is not flooded in the previous case and flooded now. See the we clearly see that pixel right. That pixel we will take like as aerial or aerial polygon means some 3-4 pixels will be there right. That's the thing, means mining manually means a simple our class satellite image supervisor classification, no, it is not like that. So we have to train like a the whatever the equation like a whatever you say like a random forest, there is algorithm will be there right. Data training time there is one schedule will be there. You have to output flood. So the pixel you are giving also some this thing will be there. So it will go on train and you will give the kernel values those things. So those things that is a one kernel function, okay, one training function that you apply for the real time data. Like a random forest one way you train, like a SVM one way of training and that they are like a different way of training process. Okay. Any other questions? So this is one way of doing. So many other things nowadays is evolving anything like anything means what I am saying like it's totally like a every time you see every few days like there is saying like one more new algorithm actually. So it's like a lot of we can say new things are coming in this domain. You are really interested like you said somebody like a geography they are saying, they said that what type of things to study means this all will like really you can think of really something can be done with all your those things cases. Okay. So can we stop at this point and take exactly that means maybe 5 minutes break or otherwise you see the snacks are there. Huh? We will break then for 5 minutes. 5 minutes we will break. Yeah. 8 minutes like now 10:37 like they can met 10:45. Yeah. Yes. So you can join back at 10:50. That's the biggest break. Later we will only get the.
Okay, when you are settling down, I just wanted to show you something about what we are witnessing on the screen here and also what we went through yesterday with our field visit. So I will talk about briefly what we observed and how it's done behind the scene, or even when you were there after we came back to that office, they showed us the calculations and the charts and everything. So it stimulated a lot of thinking in me. So I thought I would share my own excitement about what we saw yesterday, and that will actually kind of train your thoughts about how you can think when you see the data. So that's the connection I would like to establish in the first 15-20 minutes, and then I will talk about a topic called integrated water management, because when we talk about hydrologic extremes, mainly we were focusing on two things: floods and droughts. We give you the tools, we kind of suggest you how to do those kinds of analysis and modeling and all that, right? But at the same time, taking one step backward, or even I would say a bigger thinking that you want to have under these extreme scenarios, what would it take to really consider all aspects of watershed conditions, and how can you think about integrated modeling? It is not just one thing that's happening, right? Yes, you can quantify floods, you can quantify drought, or you can map them like from our previous discussions. Okay, then you will ask the question, what next? How do you connect the remaining things with these disasters? How do you manage this system, right? So that's how the integrated water management comes into play. We will not talk about again how do you model watersheds in an integrated way. All I am going to show you is that there are topics that will happen or occur, there are incidences that can happen in terms of quality, quantity, pollution, right, and those kinds of things I will try to connect on the theoretical side. But of course, if time permits, today itself I will talk a little bit about the modeling concepts for SWOT for tomorrow as the last part. So that may help you again think about how the model works on a theoretical level. But then tomorrow, I think we are swapping, right, some of the things that we are discussing today. Again, machine learning is moved today, and tomorrow we will have the whole afternoon for introducing you to SWOT modeling. Start from compiling the information to running the model. So that's a similar exercise that you did for HEC-HMS last week or HEC-RAS, but we will do that with SWOT model tomorrow. So with that it will end. But again, on the theoretical side, I will just give you a 3-day outlook before I start with this one. Tomorrow we are still discussing whether to go with adaptation. What do we mean by adaptation in terms of climate change, and then what are the new developments that happens with respect to climate change on a bigger scale. That is one type of approach. The other thing is we need to identify the research areas for adaptation. When you want to do research, I mean there are so many things, but we are going to tailor our research topics very closely connected to adaptation. If we want to make an adaptation approach, take an adaptation approach, what are the research that you would want to do? That kind of a topic that I am planning to cover tomorrow. The last day is about how to do research. Some of you are basically starting your career, scholarly work with respect to masters or PhD. Some of you are at the undergraduate level thinking about graduate school. So for all of you, I think it might help just to define basic stuff about how do you set your goals, what are the objectives, how do you define hypothesis, how do you undertake research, those kinds of generic settings that I will introduce, and then how do you communicate your research, how do you publish, that's the last part. So between tomorrow and day after tomorrow, these two sections that I am planning to have, we will work with our institution here to see. There is also a larger group of people planned to come for the last one that I talked about. So depending on the majority of the attendance availability, we might move that one tomorrow, and the one I talked about adaptation and specific research would be moved on Wednesday. But regardless, it does not matter. It's more on the generic side because we are in the last lap of this 10-day course. So I'm trying to really come up with the broader questions and try to connect all the loose ends to give you a bigger picture. When you go home, of course, you are going to still focus on a very focused question, very focused research using the tools or exposure that you got from here, but you have to always kind of calibrate yourself from where you are heading, right, ultimately. And how do you do that is the tools part that you are always checking once in a while with all the tutorials that we have. That's the overall plan. What I am showing here is the map that yesterday we went. For the locals, what I call locals as those who are here in NIT Warangal or those who are doing research in this area, I consider them as familiar people, right. So, for this area, so we actually set out our travel, right, from Warangal yesterday morning all the way from the south. Did I cross too much already? Yeah, here. So, we kind of started from Warangal, right, Warangal, Orugallu. So, we traveled all the way to Parkal, right, and then on the way, of course, we kind of went to that Mogullupalli, right, and then you see here Ankushapur, now it shows up, right, that is the river that we looked at, okay. So, just to give you the context, of course, you know, it's a nice tributary that we looked at. So, I want to kind of ask you some basic questions. What did you learn yesterday? Couple of things that you can tell quickly, but I want you to think about what are the major things that you think, wow, I never knew that this is happening. Anything that surprised you yesterday? Okay, you are seeing for the first time the instrument that's used for measuring the velocity, right. That's a good you know way of saying what you learned. What are the other things that you think that really surprised you or made you feel like, wow, I never realized this is happening? Anything? Hmm. Okay. Rating curve. Okay, so that's another highlight. I'll come to that. Anything else from that corner? Man-made lake. Okay, yeah, that's another one. But I'm confining my discussion for the first half of the day before lunch when we went to the river and what we saw. So, that part. So, just think about linking only the theory aspect of it to what you saw. Anything that kind of stood out for you to recall? Okay, okay. So, all of these gauge station measurements, maintenance. Okay, yeah, yeah, I agree. I think they are really maintaining it well. Yeah, multiple data. Yeah, 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 yeah. Right. Yeah, that is definitely organizing. Yeah, maintaining and organizing multiple data collections. Um, okay, so that still opens up the question then. So it's not a wasted effort for me to interpret little more than what you said. Probably you have this in your head, but at the end of this 20 minutes journey, you will remember what you said and how I am thinking, and then you see whether or not that makes sense, whether or not you can kind of see in depth of what we are talking about, right. So, let us come to the point here. Chaliwagu, right, Chaliwagu subwatershed, what you are seeing on the screen, the photo that I took, I am just posting it here. Ankushapur Central Water Commission, CWC gauging station, right. So, that is the significant day for us to go to the field to look at this information. Okay. Before I go to the next one, I want to ask you a quiz for somebody on this side. The water that drops in any of this place here, okay, in this watershed, where does it go? Surya can answer probably. I am just putting it on spot. I am just kidding. So, anybody here have any thoughts? When the rain comes, when the droplets of rain falls here, where does it go? Where is downstream? What is the downstream for that watershed, that what we saw? What is that point? What is that? It's all here. It's in the title. Where is it going? Why are you stumbling? Tell me, where is it going? Where is that water going? Ankushapur. What is the doubt there? Okay, that is a place it goes. Okay, from there where it goes? So, what is this sub-watershed? Chaliwagu sub-watershed, right? And then it connects to which one? Maneru. So, it connects to Maneru watershed, and then Maneru connects to where? Okay, so now you tell me the rain that falls here, where does it end up? Ultimately, which ocean? I am going to ask this side. Which ocean? Bay of Bengal. Think like that. The raindrop that falls here ends up in Bay of Bengal through 2 or 3 tributaries, from this watershed to Maneru watershed to Godavari big watershed or river basin, and then river that falls and dumps into the Bay of Bengal. You know this, but I have to pluck your mouth to bring this out. This is kind of a basic thinking that you need to have. You know, whenever you are trying to model, just it's a temptation to really jump into coding and running the model, and I want to see the results. Also step back and think, what am I doing here? Where is this water going? How is it going? So you know this, but you need to still calibrate, recalibrate yourself to think along these lines. That's research. I mean, reinventing some of the things that is already known, but for your conscience, you will try to really start from there. Okay, now I kind of brought you up to speed on this. So now let's look at this theory part. So this is how USGS measures the flow, right? So of course, little bit of automation is happening there. So don't worry about that part. You know, like gauging station, you know, the sensors and other stuff that are monitored from here. But here we saw all those, you know, whatever you call that, mark posts on both sides of the topographic bank or plains on the upper sides, on both sides, but we went into the river bottom or river bed, right? So that's where we went and looked at all these measurements, right? So what are they talking about here? These are the segments, right? These dots are the depths where they measure the velocity. Our Hema madam went inside and put the anemometer, or sorry, the velocity meter, current meter, and looked at the velocity. At what depth? 0.6 d and 0.4 from the surface or 0.4 from the bottom. You know, those numbers are recorded already for you to look at. But again, the idea here is they measure at every depth. This is exactly how they do here also, right? And then ultimately what somebody said here, is rating curve is developed, right? Q versus the stage. That is called SD curve, what we talked about in our graph, right? So I will come back to that point. So now going into the depth. So for developing that rating curve, meticulously they divide this into roughly what, 20 segments. Mr. Chaitanya, if I remember correct the name, executive engineer or division engineer who took us around, he showed us how they divide, and for each section they measure the velocity and at certain depth, and they compute the discharge, right, for each section, and then they kind of add them up. So, they of course they calculate the width, now they have the depth, so they have the velocity, so they go with Q equal to VA. So, this is the exact calculation that you saw from this sheet that they have entered for different sections. They kind of looked at distance, bank or edge. He was talking, he is referring to this as edge, and then he went all the way up to whatever width that they had. I think it was 60-70 meters if I remember correct, I forget, maybe it is all in the data. And then they looked at the width of the section, the depth of the section, subsections that they divided, okay, and the velocity that came from the measurement that they, the rotation stuff with the time that they calculated, and they converted that into velocity, used the graph or the sheet, and they got this velocity number, and then width times depth is the area times velocity gives you discharge, and then they added up, they got some flow here. This is in cubic foot per second CFS. We measured everything in cusecs, cubic meters per second. Anybody remembers what was the number? What was the number? Total Q yesterday? 4.7 or something, 4.5 or 4.7, right? So, that is a number, keep that in mind for now, So, I am relating to the table that they are developing here with the textbook example that I showed, ditto. This is exactly ditto. Such a professional way of calculating what they are doing, it is very nice, very impressive, right. So, what somebody said here as the number that you see here as the total flow, right, that is exactly what they did, width times depth, area, then velocity multiplied, then they got Q, cubic meters per second, right. They added up all of them together, they got the total Q. So, this is not so different, I think it is not so visible, sorry, but I took the picture, I think in that room did not have enough light, I think so, but you can recognize that this is the graph they had. So, it is exactly the same. So, I am trying to really see what is in the textbook to what they are doing here, perfect, very professional. Okay. Another interesting point I wanted to bring out for research. What did you see as the flow? 4.7, right. When I asked him more questions for the benefit of you, he gave some additional information, right. Was this year normal? I asked, he said no, it is very dry, right. Then we asked what happened last year or year before last. So, the 2023 flood actually even blown away that bridge, part of the bridge that I do not know how many of you recognize that. He was showing part of the bridge was blown away, water went all the way up to that high, right, and then it spilled over the banks, it really created floods, right. So, look at this number again, sorry, this is 1800, I think I tried to remember based on the y axis, annual precipitation totals for the last 3 years, 1800, somewhere around 1500, last year 1300, this year it is even less, so far below average precipitation, in fact significantly. And that was the flood flow that we had for 23, I think, the one they showed where the bridge flow happened, and this flow, this is stage, this is discharge. If you look at, it is nearly 0, 4.5 cubic meters per second is nothing, right. What we saw yesterday is minimal flow, and of course, this season alone is having so far very less. This is, I think, I cannot remember, this is June, July, I think. So, we are in the beginning of August. So, the flow they are going to record here as 4.73 something, right. So, monthly discharge plots, if you look at for multiple years, of course, it starts gradually, right, from June to July, August, it is normal to see a declining flow around this time by the end of the monsoon. But this year is extraordinarily, even the highest amount that we normally should have around June, July is not there, right, and it is going to go down still in the next month or so. So annual flow, again starting from that year, if you look at gradually it's decreasing. So now there are some things that are already cooking. What is cooking? Maybe my question is not clear to you, or what I am expecting probably is not conveyed to you clearly. I showed you precipitation is decreasing. I showed you from year to year stream flow is decreasing. What should immediately have a trigger in your mind right now by looking at the settings? Going through some possible drought. But do we realize that when we were there? Probably. Who realized it? Sorry? Okay. Okay. So you had some grasp of it, but you did not know. So that is the challenge that I talked about when it comes to detecting the onset of drought. We are already heading to some kind of a multi-year drought here we call. So multi-year drought, year 1, 2 and 3, if you are seeing from 23, this is third year, we are seeing a constant decline of flow. Precipitation is also relating. So what next? What can I think about? Of course, I will have a little detour and then come back to this. So post monsoon, they are looking at the channel conditions, and then they quantify channel elevation or something like that, I guess this one, but they use this in the Chessie's formula here to calculate the Manning's roughness coefficient, which is used in hydraulic calculations. The other day when you did HEC-RAS, this is one of the parameters that we kind of assumed, and we put that number as a constant number, but meticulously here they are measuring pre and post monsoon, come up with a new value of n every time, assuming the landscape has modified upstream and changes the river bed by bringing sediments and rocks and boulders and whatnot. So that changes the surface conditions, which will impact the flow, flood flow calculations. So this is another meticulous calculation they are doing. So I am so impressed with that. So now we already jumped into that question that I asked, and you answered the question, right? So let's actually look at 2 or 3 variables. I think this is the same slide that I showed before. I am actually now showing all the variables. So we have seen the data real time, I mean measured with their own instruments and entered in their own logbook. For 3 years you have that data. We have 3 years of data for stream flow. We have temperature data also. We don't need to worry about the remaining thing. So you have some of the important ones that are really measured up, close from the field. You have the data. What can you do with that data? What can you do with the data? I am just triggering your thinking. Those who go back and probably want to pursue some research even based on this question, what can you think about doing research on this? I want you to, I don't know whether you read all the literature that I gave you on droughts and papers and all that stuff. You remember one index that I talked about called standardized precipitation index? If you plot that graph, I mean just precipitation alone, multi-year, of course you don't just take about 3-year precipitation only, but go for a longer period, you can kind of generate a graph like this. And for the last 3 years, how will our graph look like for this site that I am talking about? It will show below this line, right? Below average, it is decreasing, it is showing the negative number. Anomaly is negative from the long term average precipitation that you are going to see, right? Let us say on an average it is about 1500 millimeters. Now you are seeing for year 3 below that 1500 millimeters. So can you calculate SPI based drought index for that watershed? Possible, right? And then what next you can do? You have stream flow. What can you do with that? I talked about former hydrological drought index, right? What is hydrological index? Again, I am recalling all our discussions that we had. This is, of course, we talked about pHDI, of course, with the moisture anomaly. In this case, of course, you have precipitation, you have P cap, which is calculated based on the terminologies that we approximate, PET minus runoff minus rainfall runoff losses, right? You got rainfall, you got runoff, leave out, of course, calculate PET approximately, you can calculate based on temperature, but then assume that there is not much loss, but you can still calculate P cap and come up with the Z anomaly, right? And that Z anomaly is used here in this calculation to come up with, this is on a monthly time step. They have monthly data of flow, monthly data of precipitation, daily also, but I am saying aggregate them into monthly time step, and then if you plot them, you can even calculate pHDI based on stream flow, because we are seeing stream flow is decreasing consistently. We have valid data. What a wonderful thing that can be, basically to see you have data to validate, and this is absolutely going to tell you that this particular small watershed itself is showing the signs of stress, both based on SPI and pHDI. You can do many things, many other indices built on this, remote sensing, machine learning, whatnot, but this is just the starting point for you to justify your motivation for why you want to do research. Just with 1 or 2, 3 hours of time that we spend there understanding the terrain and places, you feel like you can somehow dig the gold mine beneath the data. That is what I am trying to get at. So, I just wanted to kind of tie all the loose ends here. This is how you will look at the data, this is how you will connect with the literature. Do not expect somebody to come and give you a topic for doing research. It is also possible for you, if you pour through the data and dig the information and see overall, we are all not just engineers, right? We are all not just engineers. Then who we are? Also doctors. Why? We are fixing the planet Earth, the health of the planet Earth. We are doctors. If you understand like this, the settings, and understand what kind of questions you can ask with the data that you have, and what kind of medicine you can give, what kind of adaptation measure they can have, what kind of conservation they can have. Those are the solutions, medicines, prescriptions that you can provide with, right? So, you are not just engineers. Take that away. Take that concept into your mind. So, anyway, now of course, think about the questions that I asked in the beginning of the session for this watershed, and then we dive in deep into the discussions about how I see the data. Maybe you will see totally different. You may have more information, but the only substitute for research is what? The only substitute for research is hard work, looking the same thing with a different eye, okay? With a different eye, with a different thinking, and come up with always a burning question that you want to answer. So, that passion, that cultivation of interest and excitement is very important for research. So, I thought my stay there for limited. Some of you will be revisiting that place. Some of you will probably look at it from your own watershed when you go back. And again, this is not just Ankushapur, right? I am talking about this may be spreading, this may be more intense. So, then we are talking about severity, area, duration. So, with multiple CWC stations spreading all the way from Ankushapur to Maneru to Godavari, want to look at all the signals, all the signatures of drought, and then maybe you can say, when there are things that you may not know, like when will it end, but we are already in it, that we can say for sure, because it is already year 3, we have deviated from the average conditions, the drought has already started, that we have not realized. We are right in the epicenter of where the drought probably is happening. You will probably come to know next year around this time, probably when the farmers are going to suffer with low yield or no yield, then it will become news for you, but now you are even seeing this. So, to break this cycle, you have to have extraordinary rainfall to compensate for even to come back to 1500 millimeters of rainfall, which will trigger normal flow in the river. So, again, one approach is of course to look at, is it bringing rain. So, now I am giving or I am creating interest in your thinking now, you will now when you go back, whether you go to Roorkee or you go to Thiruvananthapuram, anywhere in between, you will see what kind of big storm that is going to bring rainfall to Ankushapur. I want to see the CWC data, how it is going to respond to the watershed. You can remotely access and see what happens to this watershed, and then you think about what you can relate to your own places. It is possible, right? That is research. That is research. Try to really see what breaks this. How do I really understand that, and how is the impact on this? So, I mean, it is a detour from what I wanted to talk about, but I thought it is worthwhile to connect the dots of what we saw to what is happening. I mean, how you can calculate certain things based on science that you are learning from this class. Questions? Okay. So, I kind of covered what I wanted to cover. I think they have created a folder for posting all the photos. I see some posted already, but make sure that everybody posts there. I think I saw Gracie's photos. I think I saw Harsha's photos. So, rest of them have taken photos too, right? So, pour them here, put them over here by today. So, that way we can download them. I will also post, I have to do that too, but I was working on creating the slides that I wanted to show for this class for today. But any questions on that so far? If not, let me move on to the next topic, which is general circulation models. Again, I am going, we talked about Ankushapur point scale analysis, but now let us look at general circulation models. Now, you all appreciate after visiting INCOIS what we mean by circulation, right? I mean, global circulation, land, ocean, atmosphere interaction, all of those things matter, right? So, these GCMs are complex computer programs that describes how the air in the atmosphere moves, circulates around the globe. But when they say specifically atmosphere, it does not mean they are totally disconnecting the rest. The motion in the atmosphere is linked to what happens on the land, what happens on the ocean, right? We know that for sure. So, the integrated ocean land atmosphere model is this GCM, okay. So, you will have to extend your understanding on that. And GCMs are like your bank account, atmospheric bank account. They calculate the fluxes, the motion, the volumes of water or vapor that comes and goes for each defined area that corresponds to the surface on the ground, right? And then of course, they add them up like they did for stream flow yesterday by every time step. In this case, every space and time step they calculate brick by brick or block by block, and then they come up with the total amount of moisture that we have, or total amount of fluxes that we can calculate. So, this is the schematic. I may have shown this before, right? This atmosphere or the globe is divided into grids, both from the spatial scale point of view and the vertical, horizontal as well as vertical scale. For every pixel they calculate the fluxes, right? And then and based on the location, some places they have taller atmosphere, some places they have shallower atmosphere. The column will change within the model, but the height of each volume of course needs to be subjective to the ground condition, and they are going to add the fluxes for each of these pixels together ultimately, right? The time step for variables chosen should be carefully done, because these computer programs are run in supercomputers most of the time. Even though they are fast enough, they are also unstable, or instability can be coming in there. Unstable conditions and instability can come in the calculations. So, 20 to 30 minute time is the typical time they chose for every 100 kilometer grids, and they run for the whole globe, this whole thing. The INCOIS example is focusing mostly the southern part of Indian Ocean, all the way from what Arabian Peninsula to all the way to east up to Indonesia, around the region, Malaysia, Indonesia region. But this one, if you look at, they are considering the whole globe running. So, they have to look at how the ocean heat content is moving, how the circulation is happening, how they can calculate the fluxes. And again, I think I will have to talk about the atmospheric rivers in this case, but I will come to that point a little later. The sequence of GCM operations are like this. I think the fonts are little smaller, but it can be still readable. Initiation is the first step always. 4-dimensional data assimilation, 4DDA they call, for every state variable. Whenever I am saying state variable, meaning the variable that changes with every time step, that is called state variable, and it could be water vapor in the atmosphere, that is a flux, that is called a state variable. Soil moisture in the soil is a state variable, dt over, or d soil moisture over dt, that is a state variable. We are talking about for every time step that we calculate that variable. Those are initialized within the model. Once you initialize, you calculate from the previously defined fluxes within the model time step, you update those values with your values, and then of course you run it, and then calculating the physics, and you are going to really look at how they are diverging for each of those boxes that I showed from the previous time step. We account for those changes, and then we have to smooth out those divergence and come up with again the simulation until the divergence is really small. So, when you are talking about every simulation, every model will follow this kind of approximate steps: initialization to solving the dynamics to update from the previous time step, and then after outputs, and then you calculate the physics and calculate the divergence of it, smooth out the divergences. It's done repeatedly until you get this done. Of course, humans have done this before, but now AI, ML, DL are doing this for us. Meteorology is one place where ML and DL techniques are really widely used, because it's a lot of work, it's more or less monotonous, or it can be taken from all the observations, satellite observations, then they train. They talked about it in INCOIS also the other day, but again I think we need to be considering the theory of what's happening behind all these things, initialization to updating the fluxes to calculating the divergences to repeating the whole thing over and over and over with the new data that's coming in for every time step, because people are coming up with new estimates of all the atmospheric conditions through satellites every few hours. So, they have to update. If the model is diverging too much, it means it's not updated correctly. So, that's why we want to update that. So, that's a general circulation model framework whenever we are thinking about all these model outputs. But again, I am coming back to our domain, which is hydrology here, right. So, we want to talk about how climate change is impacting hydrological cycle, which we talked before, but again when we see the global change impacts on hydrology, we do not want to just look at stream flow or even specifically looking at one condition or the other, like floods or droughts, right. We want to see how the whole setup is going to be impacted and how humans are impacting it and humans are affected by it. It's a two-way process. We create problems and we are ending up in our own problems. We are subjected to getting into our own trouble. For that reason alone, of course, we want to understand what kind of emissions that we have in the atmosphere, what kind of land cover land use change, what are the management practices we are doing, and then how are these operations of these facilities are done in the real world, right, like water management structures, dams primarily I am talking about here, and then probably all the other smaller structures that we are having, maybe ponds, maybe the storage structures, diversion structures, all of them included here. But global climate change, I showed you the climate models, right, the complex 4-dimensional data assimilation, how it's done with initialization to updating fluxes to divergence calculation to rerunning the whole thing, right. It's done again based on the atmospheric conditions all the time. But again, we have never considered what is happening with respect to the change that we are introducing with respect to all of them, right. This is to some extent accommodated, I would say. I will not say totally it is ignored by these climate models. How do they accommodate this? Greenhouse gas effect, how are they accommodating in the GCMs now? You saw those RCPs, SSPs, right? Those are different scenarios of greenhouse emissions in the atmosphere, right? 4.5, 8.5 watts per meter squared radiative forcing because of gas in the atmosphere, right? That is the condition that we have. But we are not totally convinced of using land cover change, or what are we doing with respect to management practices, how are the dams and other water facilities are impacting the hydrologic cycle are not understood, and how that will impact climate change is not also clear. So that is a big unknown here, that is an unknown research that people are trying to ask. So the scientific question is, what are the relative impacts on the hydrologic cycle of climate variation, greenhouse warming, land cover, land use change management, direct alterations due to water resources management. We are talking about climate change impacting water resources. Even in our previous drought analysis that I was talking about for Ankushapur, I just mentioned climate change or maybe some monsoon failure which is actually leading to drought problems as of this year, right. But how these structures that are modifying, whether it is a bigger structure like Nagarjuna Sagar or maybe some other structure in Krishna, Godavari, that may be also impacting or aggravating these flows and climate conditions around it. So anyway, we are very good at modeling large small scale watersheds. You know how to model for a given watershed, you will do that for tomorrow using SWOT model, very good at it, and HMS you did for Netravati, for example, right. And again, uncovered, you can uncover, and many research in the past have uncovered what is the connection between precipitation to rainfall to runoff, tons of literature that is available, right, and the integration between different things like surface water, groundwater dynamics, runoff generation and all that. And then they also look at what kind of transport of sediments or other pollutants that happen in the watershed, that also has been addressed, okay. But now we need to devise science necessary to detect and interpret the ongoing forces of environmental change. In this case, we are talking about climate change, but we are not sufficiently skilled in terms of detecting and interpreting how the ongoing change is happening. A typical example is our yesterday's visit. We do not know whether climate change is really causing that reduction in flow, whether climate change is causing precipitation failure for this year, we do not know that. If you dive deep into this research and say, yes, climate change is affecting in my town, Ankushapur, then you are a hero for the scientific community. But can you do that? We do not have that much information, but somehow if you pour into all the connections and see how that is changing on a global scale, how it is happening here, that is really good piece of work that I would say. Scientific hydrology has been practical or pragmatic, was driven by the needs of hydrological engineers. I mean, we know, I am saying practical in the sense like we know how to measure, we know how to quantify the flow and changes, but we are also good at managing the floods and droughts, but hardly passive when it comes to hydrological events. Passive in the sense, what I mean, yesterday we went and saw, it struck me that yeah, we are through some kind of a historic event here with respect to reduction in flow, and how is it going to affect was my concern yesterday. But how are we really relating that changes to the people that we need to inform? We have changed the system, we know how the system is responding, but we are not really connecting all the dots. We are waiting, okay, things will happen, maybe it will all go away when the next year monsoon comes. That is called passive response. Probably before that, in other places what I have seen, they quickly pour into these kind of situations. I do not know how many people are talking about drought in the Godavari as of today. Forget about the smallest watershed, the Chalivahu. I am saying even a bigger scale in Godavari. I don't know how many people are talking about it as of today. Maybe it should be sending alarm bells already, creating that kind of a policy consideration. And then the population increase and economic development are also really causing pressure on the water supplies. We saw somebody taking water from the riverbed yesterday to water their paddy crops, regardless of the drought. So if you ask that farmer, are you facing drought? Probably they will say yes, but I am not affected, right? But until that groundwater table depth goes below his pumping capacity, then he will say, wow, this year I am seeing drought. But again, what I am trying to say is, we are probably struggling to quickly come up with active decision making process. Ultimately we are lacking that thing. I mean, it's not in our hands to make rain god Varuna to come, but at least we want to see what kind of impact we are going to have. Can we really suggest the farmers not to go for water intense crops, or quantify exactly how much they need to water? Instead of pumping, since it's available, they will pump any amount of water. These are the adaptation measures. We'll talk later, but I'm just trying to say that has not happened, and it's actually even creating more problems that we already are into it right now. So integrated management is the important thing. So the number that we measure after 3 hours or so, 4.73 cubic meters per second, is only one metric, but we need to really think about it in the context of integrated water management, right? Integrated water management is a solution for solving the problems, because I'll show you this with the examples from the other part of the world. Again, this applies to many parts here, right? So the fresh water is divided into many other things. You can see irrigation, a big chunk is used, right? Fresh water supply, but the remaining things are for commercial, domestic, thermal, and all the other industrial use, livestock and industrial use. There is a competition, right? There is a competition between these sectors. Will irrigation get more attention compared to livestock, or will commercial and hydropower plants will get more preference? We don't know, even under normal conditions. And think about extreme scenario like this. Godavari decision making people should be really struggling to make decisions about how to balance this out. Right now they should be really having the alarm bell going for quantifying multiple sector quantity alone I am talking about. And then quality, when you talk about, we don't know how quality it's going to be, how good the quality is going to be, right? And then groundwater. Now again going back to Ankushapur, they are dipping into the groundwater and they are pumping. And I also heard during that conversation that groundwater was excessively pumped in this region in the last few years, and it will happen now, because when farmers are going to have no flow or reduced flow from these river systems that they cannot divert, they are going to dip into our reserve, the groundwater reserve, and pump more water from that. That's going to also cause problems. And on top of it, floods and droughts are creating issues, and ecosystem vulnerabilities are problems. So combining all these things is the integrated water management that I am talking about. Okay, so these are all repeats of what I earlier said, but I wanted to show you this graph, because whenever we say snow line is receding, right, it might, I mean, I could not fully understand until I witnessed going to a mountain that's covered by snow. Since I am lucky now to say that I saw the snow, I saw it was retreating, I was able to relate to what I see from the textbook, but I just wanted to relay my own experience with this graphic here. Consider this as Himalayas, lot of vegetations in the lower portions. Those who are coming from Haridwar, Rishikesh, Himachal Pradesh would understand what I am talking about. Lot of vegetations near the lower elevation areas, but as you go up, the snow level is there, 3000 feet in this case. But what happens in the future? It will recede to a 4000 level or even more. So shrinking of ice covered areas are happening already, snow covered ice. So, that is actually causing the problem in many parts of the US. For example, here I am showing for different mountains, Rocky Mountain, Pacific Northwest, a gradual decline of mountain snowpack. There is a lot of work done for the Himalayas of how Himalayan snow lines are also receding and how that is actually impacting the water supplies, right. So, Godavari for example is not a snow driven watershed or a river basin. So, this does not apply, but all I am talking about is when you consider the receding snowpack, this is what they exactly mean by that. Many times what happens is in these mountains, instead of snow, what happens? Now they fall as liquid rain. The rainfall that you normally get in the plains is coming in the top portion also. So, you will probably see rain falling on the snow. That is even adding more positive feedback because it melts even the existing snow also quickly. So, that positive feedback that we talked about in one of the classes is happening already with these mountain tops. So, rain and rain on snow events are happening more and more, and peak runoff is happening that I think I mentioned in one of the classes. I mean, consider this for normal snow year versus increased temperature year where the peak is coming earlier and the volume of water excessively harvested here needs to be stored, but we do not have structures to store them. That is the problem that we will have. And there are of course 80,000 dams in the US alone are there to kind of serve as shock absorbers or cushion to store this excess water, but some of them are old, some of them needs to be retrofitted because the height is not enough for them to store all the melting water, okay. And millions of canals and pipes are needing to be replaced. And then competition for resources, you can see population increase is steady and the demand for water supply is of course hitting some plateau here, and the demand calculation alone is a big deal for every watershed. If you think about yesterday's watershed to Godavari scale, the demand should be remaining the same as last year or maybe even more for this year because of maybe human modified landscape demands that we are talking about. Are we quantifying those demands? Probably not. And then climate change is added to that. Irrigation water needs are going to increase. Most cases it is going to increase, but in some cases it is going to decrease if they are introducing conservation measures. Like yesterday in one of the videos that I showed where they are changing from water consuming crops to nuts. In California, they were talking about how they are adopting is to put these less water consuming nuts and crops like almonds, badam basically, and many other nuts they are replacing with existing trees or existing water consuming plants. Of course, freshwater lakes are shrinking. Yesterday we went to Ramappa Lake, right? Because of the reduction in precipitation in this region, obviously a closed lake like that, which we saw these mountains around it were are sending their water into this lake, that will also decrease. So, the lake level can go down. Of course, the diversion that comes from there will also go down then, right, from the upstream portions. Then quality is also changing of this water. I am going to actually skip some of these slides in the interest of time. You can read on your own, but the main thing is quality of water, quantity of water under normal condition versus drought conditions are really another important topic that people have to really focus on. In many portions precipitation is increasing, but many places it is also decreasing, and drought is increasing in many areas that we saw. How is it going to impact water quality is a question that we want to be asking. So, quality is another factor. They are measuring temperature, right? Yesterday the gentleman actually talked about they measure maximum temperature, minimum temperature of water every day, and that is an important water quality parameter. In many places if the temperature is going to increase, they will kill the fish within the river system. That is aquatic habitat loss that we are talking about. that is also related to water quality. So, when we talk about biodiversity, when we talk about losing some of the habitats, this is an actual parameter that people look at in terms of water quality. Temperature, I am talking about temperature. Okay, the timing of runoff is changing, frequency of precipitation, which we have discussed many times, is changing. So, I guess these are impacting the pollutants, or how the pollutants will be carried into the system and how it is going to really affect the water quality conditions. So, that is not seen by most people. So, that is what I am trying to say when you are talking about integrated water management. Salinity is another issue. Those who are coming from delta, for example, Ganges or Brahmaputra or even Kaveri, for example, in Tamil Nadu, some places you are having already salt water entering into the system. Basically, that is creating both fresh water becoming saline water, and also it is creating waterborne diseases in areas where we have flooded conditions. Because what happens is, when the flood happens, you saw the maps. I have some other slides that I will show, the Houston floods, where all the urban facilities were inundated, both water treatment, freshwater treatment facilities, drinking water, as well as wastewater treatment facilities went under water, and it became so polluted, the whole area. People had to be evacuated for that reason. So, when we talk about floods, now you asked some brilliant questions this morning. Can we measure the depth of water? How do you measure? So, those are the things that you pay attention to. DEM, or how do you subtract from the land cover land use from previous time step to current times and see the actual depth and all that. Your machine learning algorithms will do all that, right? But what are the implications of it when you think of it? Depending on the depth, depending on what kind of infrastructure went under water, you will see the impact of it right away based on the conditions that what we are seeing with the water quality in this case. Okay. So, groundwater is another important thing. I mentioned, I related to our first hand experience yesterday, that people are going to pump more water this year. Just if somebody wants to take that as a research question to ask, what is going to be the groundwater withdrawal, how it is depleting the aquifer for Chalivagu or Godavari, even all the way. You can check that out and see how much of an impact it has created in terms of extracting that water. And then of course, it is also can be related to climate variability and climate change. Many streams rely on this groundwater supply, but if that groundwater goes below, they are not going to have base flow in them. You saw dry bed yesterday around this time when we were walking on the river. Many places, of course, it was little soggy, wet. You could see that when you were walking, cushion surface. Those are fed by groundwater system, right? But there are more people coming and sucking that water through their powerful pumps. You will see really dry beds. That means you are dropping the even groundwater table elevation below that water table. So, that is going to actually impact the conditions there, and of course, we can quantify that and keep that as a research question. So, this is happening all over the place. It is not just happening in one place, but it happens in other places, and chemical contamination of groundwater is also happening. People dump lot of things into the surface, and it finds its way through septic tanks to other means. Basically, it enters into the groundwater. We are focusing mostly on the quantity side of how much water table drop we have, but we can also think about what kind of quality of that water is going to be. Is there going to be arsenic pollution? Is that going to be irrigated again into the rice fields? Will we then end up consuming arsenic through rice that we eat? It is a full cycle that we can ask these questions, right? I mean, this is already happening in West Bengal and Bangladesh and many places because of arsenic pollution in the groundwater systems, right? Again, coastal groundwater pumping is happening a lot, and that is actually even aggravating the saltwater intrusion into the mainlands. That is another problem, and I will skip this floods and droughts issue because we have talked plenty of times on this. But ecosystems are vulnerable now. Many of these rising temperature conditions and flow conditions are impacting these ecosystems. And think about Ramappa Lake, right? We saw the lake lush and green yesterday. If it dries out, what happens to the cultural heritage site that we are talking about? What about the vegetation that's around it and all the areas? What about the people that are relying on the fish from that lake, or ecotourism? People were boating in the stream, right in the lake. So how will it will affect both ecosystem and those who are dependent on it? It's all not completely understood, and again it's causing problems for both in terms of quantity and quality of life for people, ecosystems, when we are not maintaining it correctly. And then of course adaptation strategy, we need to do, I mean adaptation I will talk about it a little later tomorrow also, but what we want to do is to increase the ability to shift water from within and between sectors. Do we have that flexibility or agility to move water from irrigation to urban systems, or from urban system consumption that is reduced to increase the irrigation? We have not done those kinds of analysis for adaptation strategies, at least on the simulation side. If you want to do, that is a thing. And then of course water is valuable, right, pricey, and are we pricing it? Probably not. That's another adaptation strategy if you want to consider. Incorporate potential changes in demands and supply. This is a big topic. I don't think it is being focused in many parts of India, for example, right? Many parts of India, this particular aspect is not understood fully, and it is going to contribute significantly to adaptation strategy. Create incentives or requirements to move people and structures from floodplains. It's an adaptation strategy. You look at the structural damage based on your AIML flood mapping, whatnot. Ultimately you need to see how can we protect people, how can we protect these structures, right? That is adaptation strategy, or even helping them to move. And then identify ways to manage all available supplies, including groundwater, surface water and effluent, in a sustainable manner. And that is a key point, but again we are looking things in isolation, everything separately, because of overwhelming data, overwhelming demand for other things. We are not looking all of them together. So that's where integrated water management comes into play, and unless we do that, sustainability part we cannot even answer that part. Just flood mapping alone goes only to some extent. If you want to really take sustainable methods or approaches for your water management, we need to think about how do you do this integrated approach, right? I think I am going to stop here, and I will come back maybe with 6 minutes break. Let's convene again at 12 o'clock, okay? And then I'll maybe I can even start with the video, and then talk about atmospheric rivers. I want to talk about, for example, we talked about drought, right? So how is it going to change unless we see some kind of a heavy rain producing events? I'll talk about that when you come back. Okay, we'll stop here. Maybe he can stop the video if he wants to. 6 minutes break. Maybe within this year, we don't know, but that kind of a phenomenal event, that what they are talking about, 10 to 12 inches of rain, 250 millimeters of rain, in our calculations, our classification that you saw earlier, more than 200 millimeters or so they call extreme rainfall events, right? So in our calculations, the first or the second day that I showed, so this will come under that. So big rivers that flow in the atmosphere, dumping lots of rain over a large area, creating such a massive amounts of flood, is a good thing for a state like California, because they can store that water. But when it happens in a place where you don't have enough storage structures, there is a problem for that. So, and even like he was mentioning, even with those places where you can use this information on how much to release before these big storms happen, then they can even keep the level low to make sure that it can accommodate fresh inflows into the reservoir. So those are the reservoir operation management strategies for both extremes, both under extreme drought conditions, how optimized you should be in terms of releasing the water, and in the flood conditions, how do you release beforehand to make room for excessive inflow that you will have due to these heavy rainfall events. So, this is an integrated management strategy that I am talking about, connecting to the previous discussion. When we talk about floods, yes, it is important. That is the first important step to really quantify the the mapping areas and depths and all that. But then what next? You have to ask that question. So, it comes with that question on how do you allocate water resources, or how do you protect public, what kind of evacuation that you need to be thinking about. So, you will be, today you are engineer calculating all these things, tomorrow you will be a manager, maybe next day you will become even a policy maker to look at a bigger picture thing. So, these are the connections that you will establish. You will not be just looking only at the smaller scale or finer scale details, but you will look at the bigger picture. That is what I am trying to bring about here. Questions on that? So, this one or two slides that I left with, I just wanted to show you here quickly. Bear with me on this, I will quickly do this, because in the visit in COIS that we actually saw, it's okay, thanks. In COIS, they talked about how the land management practices are taking all the fertilizers that we apply to agricultural areas, how they are carried into the river and how they end up in the ocean or Bay of Bengal or Arabian Sea, and how they create nutrient rich environment where they grow lot of phytoplanktons and then take up all the oxygen from the area and creating a zone called, what is that zone? What is that zone called? Hypoxia, right? They talked about hypoxia, right? So, it is primarily depleting oxygen, killing all the aquatic habitats and species in those areas. It is connected to extreme events. They are kind of flushing out all the big pollutants from the river, from the land into the river and to the ocean, creating big hypoxia zones, lack of oxygen to survive. So, fish will come out of those areas, escape those areas, try to come to the ocean even thinking, or to the land surface. People go and easily catch, but we do not know how these dynamics are working. But on a global scale, of course, it is a big problem. Assessment of pollution fluxes to inland and coastal water is a big concern, and India has a long coast. You think about just on that one question of how extreme events are going to carry all the fertilizers that we apply in the Godavari basin into Bay of Bengal, and is it going to create more of hypoxia zones? That is a lifetime work for somebody to do that, and quantifying how much we pollute the land and how it is ending up, right. Shift in nutrients, nutrient delivery ratios contributed to coastal eutrophication, toxic blooms and hypoxia, anoxia conditions, right. And then land based human activities are blamed. We are talking about that. Non-point and point source. What is the distinction between non-point and point sources? Can somebody tell me what is non-point? Okay. Yeah. Yeah. All of the answers above, what you mentioned are correct. Main thing is it comes from a larger area. It is not a point source, right? Non-point. Primarily non-point is related to agricultural lands, because that is where we pollute by putting all the fertilizers, pesticides and what not. That is called non-point. What are the point sources examples that you can think of? Industrial pollution, wastewater effluents, they directly put in the river, they end up in the ocean, right. River is a pipe flow, basically it can find quick flow into the ocean, right. So, people do not realize that, whether it is Ganges or other big systems in many river basins here, dump all these pollutants into the river, which is ending up in the ocean. So, it is a closed circle, cycle that we are talking about here, and it creates a problem. We create these problems, and of course, long term series of sediment flux on many rivers suggest a declining fluxes to the coastal zone and imply that sediment and carbon are retained by the reservoir. That is another important thing, right. So, these fluxes are arrested, blocked, barricaded by the dams, they are stopped. So, even they become really the source of I mean, if the reduction in sediments happen in the coastal areas, what is the detrimental effect that you can say? Maybe I will have to ask somebody from West Bengal here who are familiar with delta and areas of Sundarbans and areas. Can someone tell me what happens if there is a reduction in the sediments to these coastal zones? What happens to the dams? I mean, what happens to the coastal areas? Okay. Flow. Do you agree? What do you say? So, my view is this. You are talking about flow that is affected, flow decreases because of the dams, that also decreases the sediment transport into the delta region. When you lose the sediment buildup in the delta, you are losing the land to the sea, because sea level rise is already happening. They are finding its way to come to the land. So, there is more salinity that is coming inside the land now. Saline issues are becoming more and more common, all these deltaic systems. That is a big problem right now. They are losing fertile lands, they are losing Sundarbans that you mentioned, mangroves, and it is a problem probably in other places. In Tamil Nadu, for example, there is a place called Pichavaram near Chidambaram. I do not know how many of you have seen that place. It is a mangrove area. People are measuring fluxes and they are finding out salt water entering into the system there. So, that is a near situation, a possibility that we are talking about when it comes to seawater entering into the area. So, we are losing the ecosystems, we are losing the land to the sea, we are also losing the fertile lands that produces agriculture because of saline water intrusion. This is not just only for India, there are many basins like that. The Egyptian Nile Delta system is going through the same scenario. The Mekong River basin I talked about in the first few days in Vietnam Delta region, they are losing lots of lands. Mississippi in the US, the same scenario is happening. You can name any continent where these big systems that are really affected by these dams that humans have built are modifying the flow of sediments or fluxes in general, and that is creating problems also. That is something to think about, consider, okay. And quantifying these ongoing changes to river basin development and how climate change is also impacting and then what kind of variability that we have with respect to water and materials. When we talk about materials, sediments and other fluxes during episodic floods remains an important topic. This is a very relevant and interesting, intriguing topic, and nitrogen is a big problem, right. Nitrogen that we apply through fertilizers is happening all over the place, and it is a building block of plants and animal proteins. It is also essential for all forms of life, but excess nitrogen from human activities such as agriculture, energy production, transport is overwhelming the natural nitrogen cycle. Of course, you have nitrogen in the atmosphere also that is settling into the water bodies, but the one that we have here on the land is also directly impacting how they are getting transported and into the river system and creating algae problem, algae blooms problem, that we are seeing. Suddenly the water become green, right? Those are algae. You saw in Incoy's discussion, that's good for fish, right? Because they come to eat. right? They deplete all this biomass or phytoplanktons or chlorophyll, green stuff. They're on one level it's beneficiary, but on the other level of course they can also become depletion of oxygen sources, and as a consequence of course it becomes a nutrient limited situation for us in many systems, particularly in the unnatural or undisturbed natural systems. Okay, and driven by massive increase in the use of fertilizer, the burning of fossil fuels, and upsurge in land and land clearing and deforestation, the amount of nitrogen available has doubled actually. In fact, we have put more nitrogen than what is needed for the plants, and they are not stabilized there. They are getting washed off into these water bodies due to the extreme events that we are relating to in this class. And of course, they are quantifying the amount. Nitrogen saturation can absorb soil chemistry, leading to loss of other nutrients such as calcium, magnesium, potassium, ultimately to a decline in soil fertility. The productivity of soil gets decreased. That's why farmers are suffering because of yield loss in some cases, because we created that problem. Okay, excess nitrogen can also wreak havoc with the structure of ecosystems, affecting the number and kinds of species found. We talk about both inland and also in the coastal systems how excess nitrogen can impact this quality of life. I think this is just a linear relationship between observed nitrogen flux in the riverine systems and modeled systems. Again, this is just a map. With this I will end for this one. Total dissolved oxygen nitrogen export, if you look at, India is really looking red here, right? So we kind of export lots of nitrogen, and it's also correlated well with nitrogen export or fertilizer use that we are talking about. Now when it comes to competition for resources, I started this whole discussion with multi-sectoral water use and how do you quantify in the integrated framework and integrated watershed management, right? But when you look at the resource itself, rainfall or availability of water through many other land management practices, still it is not sufficient to meet the stress. We are talking about lower stress in only a few places, but majority of them are going through high stress. Look at India, for example. It is a huge red box that we are talking about here. The entire country except few spots are going to be having high stress related to water and resources. Primarily water, I would say, natural resource, but there are other resources that are also impacted because of all the changes that what we are talking about, population and climate change, induced change. So this is kind of a full circle now what we are coming up to. I mean, we started talking about small scale events, whether it is drought or floods, and then we looked at on a river basin scale. Now continental scale, if you look at not just one region, right? We are talking about South America. Amazon is completely affected, or at least some major regions within the Amazon region. Argentina, Chile, Peru, all these Ecuador, western countries, and then most of US on the eastern side is impacted. Central Southern Africa, full of red. China, even Europe, all of these major continents. Australia, on the coastal side. Yesterday you saw a drought video that I was talking about in this part of the country, and they are saying how bleak the life is with respect to cattle ranching. They had to sell those cattle before time, before the severe drought comes, to save their profits or whatever. And now we are talking about one way or the other similar scenario in many parts of the country here, many parts of the continents, other continents. So again, there is no end to seeing the stress because we are always finding that it is going to be a stressed planet. So we need to think about how can we model things that will help us understand, build a better future, for sustainable future. Adaptation is the one that we think about. For that we need models, we need data, we need tools, right? So we are going to jump into that part, between now and tomorrow, and then conclude this whole thing with doing research and communication of that research. So, okay, now I will be quickly reviewing the basic stuff that you already saw one time, but I am going to repeat this again. Please bear with me. This is a repeat because you wanted to know little more about SWOT model, but I don't want to just introduce this as a tool for you, right. In different settings, our scholars also have given some basic information on the differences between hydrologic models. Again, it is a repeat, but for those who are here listening to hydrology for the first time, it is not a bad thing, because it is reinforcing your thinking. It will help you to get some grounding on this topic. These models are mathematical models, right, equations that we describe the processes, right, but again it can be classified, these models, as lumped model. I call Heck HMS as a lumped model, and distributed model is SWOT. One particular, I mean, in fact you ran with only one basin, with only one parameter for the entire basin to quantify Q, like vegetation or other parameters, precipitation or something like that. We we ignored the spatial variability of that watershed, Netravati watershed that you simulated, and that is a lumped model. Distributed, when you run, for example, tomorrow, you will divide the same watershed or another watershed with multiple small watershed. You can refine all these water budget, energy budget components by each sub-basin based on vegetation, land use or slope and weather conditions. You can divide these into smaller units and come up with a better estimate. So, that is a basic difference. There are other models, event and continuous. Heck HMS is an event model. Heck RAS is an event model. You took few hours, 22nd July to 21st August, you simulated one particular rainfall event. You came up with a flood producing storm hydrograph, right. So, that is an event model, and continuous model is a SWOT model. You can run the model for 5 years, 10 years, 100 years and say how my hydrographs are changing. This is basic stuff, but I just wanted to still reiterate on that. Stochastic versus deterministic. There is some randomness in this process, right. So, which is introduced through stochastic approach, that is called stochastic modeling, statistical model, and deterministic is the measurement that you can provide for these observations, and that can actually provide you the output. That is the deterministic approach. Numerical versus analytical. Many times some of these numerical models, the equations that we define has a solution, but analytical models may not have that. So, the difference between these two really needs to be understood when we are talking about how your iterations are going to matter, how many times that you would simulate. You have an abstract answer through one method, in another method you have to approximate those answers with some assumptions in it. So, hydrological models have a long history. I will not talk about all that. So, the first model is a Stanford model in 60s, Stanford University people came up with. Since then many models have come up. So, again we will skip all the history. If you think about listing the models, you can say for hydrology, hydraulics or ecosystems, whatnot, you have many models. These are all the next generation models from built from those 60s models, considering watershed scale analysis, right. They want to have distributed parameters for the watershed. It can simulate rainfall, complex rainfall patterns for a heterogeneous watershed. Most accurate representation of watershed is defined within the distributed watershed. Okay, I am focusing mostly on the distributed watershed now. The disadvantage is computationally very intensive and time consuming. You saw that yesterday. Some of your computers were chugging along slowly, not even producing the results, right. So, it took some time for you to process. Some of them are faster. So, if you go bigger, if you go for a bigger scale simulation and longer time periods, it is going to consume more of your computational time. And of course, you have to have that trade off. You have to ask a question, which model I would use because this is the problem that I have, or you can go the other way around, whether or not this model will solve my question. If not, then you have to go for a right model. Choosing the model is a big thing, right? Like choosing the index for whether it is biodiversity classification, or drought classification, or flood index modeling. You want to see what kind of models that you would use. But now coming to specific, once you chose a specific model, there are steps that you need to follow, right? Select a model based on the objectives, watershed characteristics, availability of data, and project budget. How much time do you have, both time wise and also money wise? Obtain necessary inputs. You are given for this workshop tutorial sessions data, right? Think about going back to your place and building your own model. You have to first start from looking at what's available for you to simulate. That is a big deal. You have to, even this morning for AIML techniques also, we talked about getting the right data, right, for right training the model. If you don't do that, anything that you do after that is not so useful. So you're going to have garbage in, garbage out. Models will produce what you give. Models can be as good as your output or inputs. So you don't want to create or put the model into question by just creating a bad input first of all. So many times in my own research, I put in a lot of effort to collect the data, to compile the data, to process them, to understand them before I can even feed them into the model. So I don't know how many of you noticed the other day when we talked about HEC-RAS or HEC-HMS, I asked Rafi to put the 3-year precipitation plots on the graph, on the board. It is for you to do the first check analysis or checking of the observations. You have to do that for sure, because you need to know what is the precipitation magnitude that you see for 3 years. Is there no data points, or 999, minus 999 or plus 999 for no data flags sometimes they use, right? So I can tell you another interesting story of how some papers produce results that are so wrong based on including those minus 999s in their analysis. It has happened before. So checking the data is very, very important in the running the model. And of course, objective study, and then choose the method for hydrograph analysis and routing methods. Calibration validation, which is an important step. Perform model simulations using various climate, land use conditions, right? So that is a scenario analysis. Now, unlike HEC-HMS, SWOT has evolved many things. I mean, GeoHEC-HMS of course can also do some of these things now, but SWOT with QSWOT basically has got QGIS. In this case I am talking about ArcSWOT. Many things are so nicely integrated that you can prepare the data, get into the SWOT model very easily, run the model without any extra effort. But there are other tools available for even interpreting the data. For example, visualization part of this model output is done through VisSWOT, and then SWOT Cup is another add-on to calibrating the model. So again, I am coming to the details of SWOT model, but there are lots of information available for this model. But what does this model do? That is a question that you would like to ask before you can choose this model, right? So we want to say that it is a model that you can run at high resolution based on how you divide the watershed into HRUs, hydrologic response units. They are based on topography, land cover, soil type and slope, right? And then so the input particularly is the driving force of the model, primarily P and T, that you use at multiple locations of the watershed, and the output that you can have is stream flow, surface runoff, groundwater, lateral flow, ET, soil moisture, so on and so forth. And there are many water quality parameters also you can have, okay? And this is how you would set up the model. Basically you look at the DEM, delineate the basin, define the streams. You can burn in the streams or you can use how they derive based on DEMs, and then define the output location, and in this case of course selecting the output and then coming up with flow calculations, calculation of sub-basin parameters, and then finally of course delineate the, I mean once you delineate, of course all of these processes are sequentially done in this case. So first thing is HRU analysis, land cover, land use, soil slope definition, HRU definition, write input files, edit input files and run the model. This looks simple, but if you don't do this each of the steps, it might create error message. We are compiling the data as we speak now, but for tomorrow's afternoon session, once when you do it, you will have a pretty good understanding. So I am going to actually show you the basics of the model again. It's a watershed model. It includes all kinds of land use. You can see forested area, agriculture, upland processes, agriculture here in this case, and then channel flow is considered, and then it covers the whole watershed with multiple land use information, right. It has all the processes included: weather, hydrology, sedimentation, how plants grow, nutrient cycling, pesticide management, basin management, this one, and then bacteria transport, E. coli primarily. So this is how it looks, right. The hydrologic balance that we want to calculate for this basin based on the precipitation. It falls on the tree or the land mass, and then of course it gets into the root system. Part of it is flows on the surface, right, as surface runoff. Part of it is getting infiltrated, and then of course part of it is flowing parallelly through flow that I say yesterday, or lateral flow in this case, and finds itself into this water body. Part of it is getting redistributed within this unsaturated zone or root zone. Percolation happens in the shallow aquifer. Some of these are shallow aquifers, and then further aquifer percolation happens. Further percolation gets into recharge, deep aquifer, and part of it is laterally flowing into the water body as the return flows. Part of it is also due to capillary action, can find itself moving up into the unsaturated zone, and of course model can actually quantify that amount. After quantifying all of that amount, after taking this loss into the aquifer which is not coming to the watershed, you get the flow at the outlet. So now I am putting out all these processes that are simulated here, including ET, which is a big quantity. You are modeling this in the watershed framework for the model like SWOT. This is happening for all the watersheds. Every watershed has got its own unique way of defining these processes. That is the only difference. A SWOT model versus HEC model, HEC HMS model, or another model, considers more or less the same processes, but how they divide or partition the quantities into different elements are subjected to the input availability, or I mean their equations, how they define these processes within the model, and the demand for the input. Okay. And now coming to the setup, we will delineate. I think this is shown before also, so I am just again reiterating. Then you will use input, and we will provide you tomorrow with land use, soil and slope maps. You will create HRUs, and then we will have climate model data or observed data, but in your research purposes you will use climate model data for extended period. Write the parameters first, that is the first step in the model, and then run the SWOT model, calibrate if you need, and then simulate. So this is the simulation that you are seeing, continuous model. So I am able to show multi-year simulation of hydrographs, right. This is for 2 locations that I am showing. So what we are saying is for a long term simulation, how the model is doing with a reasonable accuracy, monthly time step, I guess 0.81, 0.5 and 0.6 and above is always good. 0.8 is really good because we calibrated this watershed. So again for another location. So there are lots of parameters that go within the model. I think we play with few parameters tomorrow. For example, here you will see curve number as one thing, and then there are also, this is curve number, right. So we have the range, and then for at what scale that you are going to be calibrating this parameter, basin scale or HRU scale or sub basin scale, and whether or not you will replace the parameter or modify the value with some factors. R and V, that's the representation within the model for each parameters. There are about 54 or so parameters, and part of it is quantity water quantity related parameters, part of it is water quality related. We are not going to touch water quality parameters, we will touch only water quantity related parameters. Okay. Once you calibrate the model, of course, you can run the model for different watersheds. In this case, we ran for one of these watersheds, which is snow melt driven watershed, which also has got reservoirs downstream. So we looked at what is the inflow to those reservoirs. Here you see here, there is one reservoir that we have, there is another one reservoir here, 3 reservoirs that we have in this watershed. So we kind of quantified what is the amount of water that each of these reservoirs will have under climate change conditions. Okay, and then we quantified, how much each of these models are producing as hydrograph in terms of peak flows, uncertainty. We tried to bracket for 10-year period intervals for different models, and of course generally they agree, but you can see a range, small one to big one here, and the flow is very small. See, I think it is in CMS only flow 350. It's very small compared to even the watershed that you saw yesterday. Quantity of flow I am saying, but it is no melt watershed, so it is very limited in quantity. But then you can look at it on a spatial scale by HRUs or by subbasins, each variable, whether it is ET, soil moisture, temperature. Then what we did, using these parameters into some of our outputs into your calculations of floods or calculation of drought using soil moisture output from these kind of models. So you can animate these results. We did this for multiple basins within the state of Idaho. I am just showing here just as an example, but the whole idea here is to say we will kind of end up with experience on using 2 different models. One is an event model like HHMS, the other one is also a continuous model like SWOT model, and one is a lump model, one is a distributed model. So you will see the difference, and then how to customize a model, how to calibrate a model, how to visualize the output, how to relate to the real world situation that you are looking at. You could do this for Ankushapur watershed or Chaliwagu watershed and see whether or not you can calibrate the model to come up with best flow estimation, just as a trial exercise. All you have to do is to put together inputs of soil, vegetation, soil slope, and weather data. Once you do that, it's a very nice example for you to understand whether or not you get the same flow that you saw from the field. It's a nice trial experiment for you over the weekend if you want to experiment that. With that, I will stop. I'll take any questions that you may have. With that, we can stop for lunch at 12:45 and reconvene at 2:15. Right? Any questions that you have? I think it's all pretty repeat of what we are seeing overall, but I will talk about adaptation strategies and a little bit on the new research.
Small changes we made here and there, so because of as somebody's request regarding swap model and other things, so we are modified a little bit, but things are okay. Like we will proceed with whatever the tomorrow's things we are proceeding today, and we will see that everything will cover after the end of the day. Okay? Yes. Okay.
So today we are going to see flood extent visualization using Google Earth Engine. I hope some of them are good at Google Earth Engine. Anyway, we will see this. This was a simple task, how to visualize the flood extent and the land use, land cover changes classification using Google Earth Engine only. So we will start. So in this tutorial section, we are going to deal about how to add the steady area into Google Earth Engine, how to find out the necessary data set collections from the Google catalog, and to classify the pre and post flood, and finding out the flood extent. And the final part will be land use land classification by pre and post flood analysis. We can find out the difference between the 2 image and the flood extent. And for the additional part, I add how to prepare the legend. And the last step will be the exporting this data into Google Drive. So we'll start. I think I think I uploaded the drive document in the WhatsApp group. I hope everyone downloaded. So please download that shapefile of our study area. Its name is like Ernakulam L. So this will be your interface in Google Earth Engine. Everyone is getting this interface?
If I come here, my picture will become. Data download कर हो जाएगा.
So it's getting right. So next step, we are going to add the shapefile into this Google Earth Engine. So for that, go to New. If anyone is facing any struggle, just raise the hand. It's sorted. Go to New. Go to Shapefiles. Here, that source file select. Select. So you can see the files inside. Just select all the files except this QMD file. Select all these 5 files. Open. So you can see like this. If any error is showing, just remove that. Somehow maybe you will click that QMD file. Just remove the file. So according to your needs, like you can change the asset name as like this. Then click upload. So here in this task, you can see the process behind this. If it is running, uploading or not like that. your tutorial what we mentioned side by side to refer this thing.
Sorry. বলছিলাম এখানে সেভ ফাইলে না ওটা সেভ ফাইল
So after uploading, you can see like this interface. Your Ernakulam shapefile is uploaded. So everyone got? Anyone is facing problem, please raise the hand. Because like this is the basic step. After shapefile uploading only we can do the study.
এটাকে নিয়ে আসবো স্ক্রিপ্টে এখানে আসছে না ম্যাম হেয়ার ইজ নট এখানে আসছে না কেন যেগুলো দিয়ে আসছে
Done.
गया ना भाई आदमी तो वो इवनिंग पे जाओ रेड में न्यू है कि नहीं न्यू में जाओ तो काटो न्यू रेड न्यू सेट फाइल हाँ बस वो सिलेक्ट ऊपर में सिलेक्ट हाँ हाँ उसको पीएम उसको एक फोल्डर रखो उसको पीएमडी पे छोड़ दो सब अपलोड करना पीएमडी जो एक्सटेंशन जो है ना उसको छोड़ दो सेट फाइल में देखना भी एक्सटेंशन है सबको अपलोड करो पीएमडी पे छोड़ दो हाँ हाँ भाई सीपीजी एमडीए पीआरजी सेट फाइल ऐसे ही इसको सिलेक्ट करो पीएमडी को मार्क
मार्कडाउन वाली ना फाइल
भाई सेट फाइल है
हाँ मार्कडाउन वाली फाइल करती है सारी
पीएमडी को छोड़ दो स्टॉक को नहीं जी ओ सेट फाइल
Select everything except for the PMD. There will be total 6 files. And the PMD and the file should be
Hope everyone got the things. Still anyone facing a problem, just please tell. So the next step will be, we are going to import this into the Google App Engine script. For that, click import. So it will come on here as like variable table with your project title. So you can modify as like this. Double click over here. Based on your need, you can change the name. Here I mentioned Ernakulam. It is the study area name. So the next step will be with this arrow, where you can see the project ID. Copy this. After copying, type this snippet. Like we are calling this from here variable Ernakulam. Is it visible to everyone? If you have the tutorial down, copy paste, because try to understand why we are writing this thing. It's just a simple snippet on, it's not like that much complicated code. Here it's main demonstrating like we are just calling this variable Ernakulam. In This is to get the feature collection. We are pasting this ID from here. After that, to map dot center object will be, we will zoom into our study area to the zooming level scale 10. This is map dot add layer will be to add this thing into our visualization part. This color will be in red color or some color like you can take from any reference. This fill color will be in the transparent. You can change over here only to 0 to 100 up to your transparency level. This will be the outline of that boundary. And in this name, Ernakulam boundary, it will be visible in our map. Anyone is facing any struggle, just open this file. It's mentioned the whole code. What we pasted over here, we will get from this arrow mark under the variable Ernakulam. We will get the ID. Copy this ID, project slash GAN project, and this paste over here. Just be careful about the syntax. If you missed anywhere, it will show the error.
Sir. Sir, here are basic problem. Sir. Sir, please change it.
So for the clarity, I will explain once more this code. So this variable Ernakulam, that's our steady area shapefile. So that what we mentioned inside the double quotation, that single quotation, it is from the ID of the shapefile we added. And this map dot center object will be If you run this code, it will just focus into the steady area, and the comma 10 will be the zoom level. You can change whatever you want, like 7, 6, like that. So the next layer will be to add this shapefile into the visualizing part, what we see over here, that map reference. So the Ernagram style, to change the style of the shapefile, we added that function, and the color will be in the color snippet code. It will be the double F00 will be some color. It is mentioned. It will, you can see it after that visualizing. Fill color same. That red color we are gonna change the transparency or the opacity opaque. Now I am giving the transparency as like 20%, and the width of the steady area shapefile we can custom like this 1, 2, like that. So the Ernakulam boundary in a single quotation, that will be the name of our shapefile. So it will come after running this code. Everyone clear? So all done this. Anyone is any problem, please let us know. We'll just sort out and we'll just move forward.
That is red. Fill color is 00 is red. Fill color is also red. And the width is the outer.
So till here everyone did, I think. So after this, we can select the whole code snippet, and here try to save your project. While each time you are running, try to save the thing. Just click the save, it will save into your project, and after that, click run. So everything you can see over here under console panel, if it is running or not, if this process take how much time to run the thing, and all you can see over here. This is what I showed, right? A map zoom level 10. You can change to 7 and run once again. You will see the change, how much it is zooming or not. So this is what exactly mean by that sender object. That 7, the number 7 means. So in this panel you can see the layers, available layers. You can toggle on, toggle off these things. So this width 2 will be the outline width, and this transparency 20%. You can change over here 30, 40, anything up to 100. And this F40 will be the red color. And this name we mentioned, it came here, Ernakulam boundary. So you can lock the layer or unlock like this. Till here it's okay, right? Anyone is facing any problem? You can save. After saving, it will automatically save over here under your project. Then next. All done. So today the section will be like this, what we studied in the Snap and QGIS on day 3 tutorial. Same replica we are going to do in Google Earth Engine. Same thing only. So it won't, we can't, like, by doing in this, we can't even see what's happening behind the pre-processing steps and all. That's why we deal last time Snap. Here it with single line. It will find out the pre-processing and all these things. By selecting the snippet, you can select all the snippet, and control backslash will be the commenting of that code. Can I move forward? So you know that we are going to be analyze the flood extent using Sentinel-1 GRD data. Last time what we did the same thing. So before that we need to mask the data. So this code snippet is explaining which data we are going to take, and the data function we are going to name it as like mask edges, and this will be our that we are going to take that image img, and this update mask image dot select vv, we are going to select the vv band. In the Sentinel it is like vv and vs band. We are focusing vv band alone to find out that proper flood extent and all. So this greater than minus 30 will be in the backscatter value. We are going to remove this minus 30, greater than all the minus 30 value, to reduce the noise and all. What we did, that thermal noise removal, the same step with this snippet. So type this. Understood why we are using this snippet? To filter the data before. So all this code we are not referring, like we can take only from any reference like that, not like that. So in the Google Earth Engine itself, you can refer to the docs area in between the script and the doc aspect. Here you can search the mask. You can find out the function over here, like that update mask function. This is what the same we are writing here. This update mask will be update the mask area, like to remove that background values or the surrounding backscatter value and everything. And this image dot select. So in the snap Sentinel 1, we are having multiple bands like VV, VS and the combined band also. So to select the particular band, the predefined band, VV we are selecting by the function dot select. Same as the greater than, you can use LT for less than, like that. So here why we are using that greater than minus 30 will be the thermal noise. Most probably it will be any other noise or something except water bodies and all. So that's why we apply minus 30. It is a standard reference to remove the thermal noise and all. While exporting last time we are giving that minus 30 free. In between the range of 30 to 40 we can give to remove that other noise values and all. So I hope everyone up till here. If anyone has any problem, can I go to next step? So next will be like we are going to find out our necessary data set. So to load the pre-flood data and post-flood data, try to follow this snippet. So actually like how we define our variable as like Ernakulam. Here we are giving S1 pre-collection. So you can give whatever like pre-flood, anything. Better to follow this because like somewhat some syntax problem will come. So better to follow this S1 underscore pre underscore collection. So then to find out the data set available in the Google catalog, we are giving that ee.image collection. This is a function to call the data set from the Google catalog. And how we found out this snippet, you can check this link, Earth Engine Data Catalog. just search Earth Engine data catalog. You will get this type of interface. In that, should I need to slow down my presentation? Is it is okay, right? So from here you can see the available data sets, collections, everything available in Google Earth Engine. These are in cloud atmosphere. You can call whatever by the cloud link and all. So we are going to deal with Sentinel. Select Sentinel. Here in the collection you can see the Sentinel-1 SAR GRD. This is like synthetic aperture radar ground range detection data. Select here. You can find out the Earth Engine snippet. This is what we just copy from here and paste over here. Same thing. Got it? Better try to type. If it is not getting, just I mentioned the Word document. Try to copy and paste from there. So in this code, like filter bound, every function you can check over here under the doc. Filter bound will be our raster analysis or like whatever analysis we are dealing with this data set. It will be bound under this shapefile what we imported. So that's why I mentioned Ernakulam over here. And this dot filter date. So we going to deal pre and post flood data. So our pre-flood data date range will be 2018 May 6th to 2018 May 20. So better care about be care about the syntax of date range. Like instead of double quotation, we are giving the single quotation over here. And these last three steps, this is a standard format to filter Sentinel data. Sentinel data is dealing the sensor like instrument mode. This EE.filter equalization we are giving as like instrument mode as interferometric wide band, like wide sensor. This sensor only gathering this data set. That's why we are mentioning this filter. And this filter list contain this polarization we are focusing on VB band. And Sentinel-1 is like gathering data in two ways. It is descending and ascending path. So in the Ernakulam district is coming under descending path. So that's why I mentioned descending over here for the orbit properties pass. So like last time we went to NRC, they show like that satellite is revolving like this. So somewhat it is missing that area in between the two revolve. So that's why it's like descending. This comes under the Ernakulam steady area. And the next step will be the select VV band. And we are calling again that map mask edge to edges to mask our data to remove this thermal noise. Getting, or like should I need to explain once again? The next line is indicating like before taking the data we doesn't know about how much data is available and should we need to mean the data or not like that. So that's why we are dealing this code like print pre-flood image count is also a function. So we are giving that S1 pre collection over here, and dot size is to represent the count, how much data, like in whatever the date range it is available, not in the date range, the count of the data availability, is it is from 1, 2 or like that. So that's why we are applying this print pre-flood image count to find out the count, how many data is available. So after typing till here, you can run and check how much data is available. Here it is coming, pre-flood image count is only 1. So we doesn't need to do that mean of the data set. Mean only. Clear, done. So the same filtering only we are applying in post-flood also. Only the change is the date range. You can see the date difference over here. It is like August 2nd week. Only this is the difference from the pre and post flood. So we are aware about this date range also.
পোস্ট ফ্ল্যাট অব্দি বসে আছে তারপরে এইভাবে তারপরে নিজে ভিডিও করছি নাহলে তো কপি করে বেরিয়ে দেবে আর কি বলে আমি তোমার কাছে অনেক কিছু জিনিস জানতে চাই আমি তো ধরে না আমি কম্পানি আমার সত্যি কথা বলতে আমি কোনো কিছু ভাবিনি যে আমি কোনটা শিখবো না কারণ শিখবো মানে নিজে থেকে প্র্যাকটিস করবো আমি যে কপি পেস্ট চলছে চলতে কিন্তু আমি যা বুঝতে পারছি হ্যাঁ বুঝে বুঝে করছি কপি পেস্ট করতে পারছি আমি যা বুঝতে পারছি আমি নিজে করতে পারছি আমি যদি নিজের থেকে করবো নিজের থেকে শিখবো
सर्च करनी आपको डिटेल डिसाइड करते हो कौन टा पर्टिकुलर একটা যে সমাজ জন্য আছে এরকম কিছু নাই
বেসিকগুলো তো সেম না
প্লিজ আপনি টাইম নষ্ট করতে বলতে কারণ স্যার আপনি
চারটে কমাই বেসিক
তো তাহলে স্যার যারা জেনারেল মানে যারা স্কুল স্টুডেন্টদেরকে শিখতে পারে ওই জায়গায় ছেলেটা বেশ কারণ ওরা ছোটো ছোটো
আচ্ছা ওটা বেসিকটা যখন আমার শোনা হয় বেশি হওয়ার পর যখন আমি রিমোট সেন্সিং জিআইএস বেস্ট আমি রিমোট সেন্সিং জিআইএস বেস্ট
আছে স্কুল করতে আমাদের স্যাটেলাইটের প্রসেসিং করার আছে ক্লাসিফিকেশন করার আছে
সবগুলো সবগুলো আলাদা আলাদা কাজ
স্পেশালিস্ট যাদের ভালো প্যাকেজ দেওয়া যায়
আমার তো কোডিং দেওয়া প্রচুর কাজ বিভিন্ন অ্যাঙ্গেলে কাজ করি বিভিন্ন জায়গায় আমি একটা করে একটা হ্যাঁ
কিছু পার্ট আমি নিজে টাইম করতে পারবো খুব বেসিক অ্যাডভান্স ফাংশন আছে বা কিছু আছে ওইগুলো আমি কপি পেস্ট করলাম ঠিক আছে
Done. Can I go forward? Yeah. So that IW is like interferometric wide swath. Like SAR is in two type, like interferometric. In that, that wide swath is covering this data. That's why we use this sensor filter also. From which sensor we need the data. So same as like this, you can run the code. You can find out the how many data count for the post flood also. So after that, to find out the date range of the data availability, we can apply this code snippet. Code snippet. It is going to print the pre-flood data range, data's date range, and the post-flood data's date range. So the same function, like to call the date range, we are using the function like pre-flood image dates. That S1 pre-collection, it to aggregate, it will convert the date range into array format. So from that array format, we are going to select only the time start, and this like dot map function to find out the time function t, and to return the date in the format of time and the year, month and date, day, we are applying this function. So try to type this and I will show the result of this code. So after typing this, you can run and to see the date range and available data count over here. See the availability of the data date is mentioned over here. See, this is what we downloaded from Snap last time. Not from Snap, Copernicus. So this is for the pre-flood data range. It's like 2018 May 17, and this is for to analyze post-flood. This is August 21st. So like this is not a mandatory thing for to understanding about the how much data is available or like which data set you have to be focused on to work on that. That's why we are just using this function to find out the availability of the date range and which data you can take for to process further like that. Till here everyone got, I hope everyone is clear about this. If any function or any thing we use is any doubt, please raise the hand, we'll see the thing. This is what like we can refer over here. Which function we need to give for our necessary needs and all. Can I go forward? All done? So next we are going to see the backscatter value difference and flood extent mapping. So till now what we did was like to collect our data set, find out that available date range and all. So next step will be the procedure like this. So here like what we gave as like S1 pre-collection, we are going to call it again as like variable S1 pre and giving that exact thing what we gave before. So the same thing, why we are doing the median means the backscatter values will be in some different range. So you know all these things, why what's the function dot median will do actually. So the function with the S1 pre-flood collection dot median, and to click into that our boundary, steady area boundary, adding that function dot clip to what we are actually doing, that clipping in the QGIS software. The same thing, this in a snippet format, dot clip boundary. So the boundary as like Ernakulam we are giving. Same step for to pre and post flood data. Any syntax problem or anything you are facing, please refer to the tutorial, that Word document what I mentioned in the Google thing. Can I move forward? Everyone got? So now we defined about our data, which data we are gonna deal pre-flood as like that, as the same for post-flood also. So this is what we are going to be deal further, variable S1 pre-flood and that S1 post also. So next step is to, this step we are giving to filter the date range, or no, not the date range, value range of the data what we are gathered. So this we can't even see anywhere why we apply like this. So this is a standard format to keep the value range in between the -25 as the minimum value and the maximum as like 2 till 0. So next is to find out the backscatter difference. Like this step we missed in QGIS. So here we can see the thing what actually working behind this thing. So to find out the backscatter value difference, we are using the pre-flood and post-flood data. Here we can apply normally in flood extent mapping. They can apply in both way. Either from difference they can find out from pre-flood minus post-flood, or the same way from the post-flood minus pre-flood. So only change we have to be care about the syntax what we are giving. The value is less than or like greater than the value. So here we are dealing about difference, taking difference from pre-flood data to the post-flood data. So this function is like variable difference. As like the S1 pre, we are defining a name for our difference raster. So it will be in variable diff. You can give as like your need. So this S1 pre will be the data, and we are minusing, subtracting, taking the difference from the S1 post, and we are going to rename this raster as like VV diff. So further for your visualizing part, you can call like VV diff instead of diff. Clear? So next step is to actually like we'll get the difference band after this, running after this. So just to filter the difference, we are applying difference band. The filter as like greater than 1.5. What we actually like earlier mentioned about the mask edge just like GT minus 30 like that. The same way difference dot GT 1.5. Why we apply this 1.5 as the dB? So you know that sentinels, our values are like taking the values in dB decibel. So it's the value range. So the greater than 1.5 will be actually distinguish about the flood extent and the existing water bodies. So you can by the reference as a standard from 1.5 to 3 you can view. So here I applied 1.5, that's why I got the proper result. So the next line is defining about our flood we found out, and this flood mask we are giving our flood mask layer as like variable flood mask. Then flood dot like same as like update mask, but we did for to filter the date earlier. This in step this same step update mask function. Here we are applying for to mask our flood data what we are extracting and to clipping into our steady. This is why we applied median to reduce the noise and other cloud or like any error or like any atmospheric variability difference and all. That's why we applied median to getting our value range in between the what we are focusing. See this pixel with greater than 1.5 drops are considered as like flooded. All done till here. Any problem? So the next step, like we need to see the things over here in our visualizing panel. Till now we did the function only. We didn't even do the what we are gonna see the thing. So for to visualizing parameter, what we defined earlier like variable which VV will be our like maximum and minimum value range, and our variable visualizing difference this band we are just giving the parameter as like this variable visualizing difference that band. So the value range is like -5. Actually like value range will be in up to any range, so we are just giving like sorting out into the particular value range is like -5 to maximum 5. And the palette this function we can as like in the QGIS we are giving that symbology changes from 0 to 1 like that. So here the -5 to 5 is just classifying into 3 color range or like 2-3 value range. It will be in the minimum value will be in red color and the maximum will be in the green color, and in between the range will be in white color. So for our visualizing purpose we can change whatever we require. Either we can give that color name as like this, or like what we mentioned earlier as like a snippet, that F001 like that. This is for to visualize our flood extent. Here that flood extent it will be in 0 to 1 value range. We are giving the 0 as like white and the blue will be the value for the value 1. done. So next step, like we're going to add this flood extent and the difference, that to raster into our visualizing panel. For that, map.add layer function we are using here, like map.add layer pre-flood data. We are naming it as like pre-flood VV band. Second, like for to visualize post-flood data, map.add layer is one post, same. So our layer will be visible in this main format, pre-flood VV and post-flood VV like this. And for to visualizing our detected flood extent map, same flood mask, whatever we are like defined over here, flood mask will be the, from this flood data is clipping into the Ernakulam shapefile. So that's why that's the what we are calling again over here with the visualizing parameter for the flood data, and it will be in the format detected flood. So if you type till here, just run the thing. Try to save in between. If you are falling in between anywhere, like you can call it again. You can see the procedure, running time, and everything over here. Everyone got this? This data pre-flood. These 4 layers, after running the code you will get. So you can see this thing, like from the data itself you can find out the flood extent, how much it like flooded over the area. So the pre-flood, like you can see all this. This is one reservoir in Ernakulam district. So this is the pre-flood image. This was the post-flood image. So you can find the difference. How much is flooded in between that 1 to 2 weeks of the rain. Same as the river also flooded over here. So this is one river in Ernakulam district, Muvattipuza river. So you can see the how much it extended, like the floodplains also got flooded. So that's why we have to extract the flooded area. We did the backscatter difference and the flood backscatter value greater than 1.5, everything we gave to find out the flood extent. So these many, the blue color region is indicating these areas got flooded or like inundated during that flood. So we can see the thing. This area around that is reservoir, and this somewhat because of some error in the filter or like what we are extracting. That's why these pixels are showing the flood extent. It's mostly the moisture content or like vegetation moisture, some other moisture or some water body, existing water bodies, other things. Clear about this? Everyone got this till here? If anyone is not getting, please raise the hand. as of now, you may know, like, you may have the doubt, what is this dark regions or what is this white regions? The people who are not from this background, they doesn't know what it indicates, like this white backscatter value means what. So for the understanding purpose, it's not the actual way of preparing land use land cover classification. For that we need to apply any supervised or unsupervised classification technique to do. So here for the understanding purpose, I created a classification of the land use and land cover by the backscatter value. So actually from the backscatter value maybe ranges from, like we gave us like this -25 and all. So from the value of -25 to up to any positive value, we are just classifying the backscatter value into 4 ranges. So the next step will be like this. So same thing, what we are applying in pre-flood, the same way only we are just applying the same methodology for to do the same in post-flood also. So here, that VV band, what's a band we are taking, VV band. So the calling like variable LULC pre-flood, same as what we mentioned for S1 post, S1 pre, like that. So for to do the analysis, we are giving the name as like LULC pre, calling that as LULC not Sentinel-1 pre-flood data, and this dot expression. What I mentioned on last time, like in QGIS raster calculator is there to filter to keep that slicing of the ranges. The same thing dot expression is doing. This function will do the splitting or like to filter the value range like this. So the value range less than -15 we are keeping as like 1. I will tell what the value 1, 2, 3 and 4 means. Same. So be careful about the syntax. And like in between -15 and -10 we are giving the value 2, and the -10 and -5 the backscatter value range in between -10 and -5 we are giving 3, and the rest all the rest of the value we are giving as like 4. 1 means like the water body or like the water, and 2 means like agriculture, sorry 2 means like vegetation, 3 is agriculture, and 4 will be the urban areas or like any other noise or like any settlement like that. So to process the things, VV is taking from S1 pre-flood data, select the VV back. We didn't even define over here what is small VV. So we are defining over here the small VV is from S1 pre-flood data, and we are renaming it as like, it will be like LULC pre, you can keep as like that also, or like you can change into this caps LULC pre. So it will visible in the layer as like LULC pre. To click into Ernakulam the steady area. The same thing applying in post also. Here in post flood we are only changes in the agriculture land. I gave us like -5, instead of here I gave us like -4. For to same purpose, for the visualizing purpose only it's like this. Right till here, we'll see the next. Done. So the next step is like same method. So we are just giving that class palette. We classifying into this. We classified earlier like from 1 to 4 the values. So we are giving that water body as like blue color, and this light green color for the vegetation, orange is for agriculture, and the red color for the urban areas and all. So this class palette, color palette only will get the visualizing areas. Next, to add the same map layer pre-flood and post-flood LULC, applying the same function map.add layer, calling that LULC pre this data, and again LULC post here. The value range is like from minimum 1 and maximum 4. Calling the palette class palette. Here it is mentioning the name as like pre-flood LULC threshold, and this is like post-flood LULC threshold. After that, run, save it. So you can see it is like running, loading it. So now it's like better visualization. You can see that how that in between the ranges. It's not an actual one. It's not that much accurate one. So from that, at least you can see. At least you can distinguish how much area is like flooded, how much area is like extended or not. You can find the difference over here in this reservoir. The water level got increased. Getting any problem? Anyone facing any problem? Should I go for? So the next step, like we found out the difference from the pre-flood and post-flood. Same way, finding out the difference from land use land cover pre and the land use land cover post. Here, see, like I am applying post-flood minus pre-flood. In this, like defining the variable LULC change and to subtract LLC post dot neq. This function is like instead of subtract we can use neq, and the self masking areas were like LLC change, it will self mask. Dot self mask will be self mask the value range, and the same to call this LLC change map into our visualizing panel. Map dot add layer we are using, and the palette, like we are giving that black. Land use land cover flood changer area, we are giving that color for that is like black. We are calling it as like land use land cover change zone. Same what we mentioned earlier, class name as like this is for our like we are going to prepare legend for this. So the one value will be water. We are giving the name as like this: vegetation, agriculture, and urban area. So this will be in the color RAM: blue, green, yellow, and red. If everyone did till here, then we'll move forward further how to prepare the legend. All done? So it's quite a long code. The thing you can copy from the tutorial that what we mentioned in the document. So what this snippet is mentioning, like we are going to create one user interference panel. This is actually, these codes are all our JavaScript. So this Google Earth Engine is work with the help of like JavaScript only. So the front end. So for the visualizing purpose, we are using the function UI.panel, and the style of the legend what we are going to create, where it needs to come, the position of the legend box, and the padding. Padding means like these are all the web-based terms. Padding is nothing but like this interface. You can see this whole page. So it will be in the 100 into 100 padding. It's a full screen. So in this 100, like 20 pixel we are giving from the left. From here it will come 20 pixel, and 50 pixel it will float up from the bottom like that. So it will come somewhat over here in the position bottom left, and the padding where it needs to keep, that will be in the format like this, 20 pixel and 50 pixel like this. And the next to define the title, legend dot add title or like add label. Like people may know about, they are dealing in QGIS, they know how we are adding the legend title, changing the font, position, everything. So legend dot add UI label, for to add the value LULC legend. It will be our title, and the style of the title we can change is like font weight, bold, italic, anything you can change over here. And the font size will be in 40 pixel. According to your need, you can change to any size. Same margin. Inside the box what we are creating, where the legend title should have to come. So we are keeping as like, this seems as like a four corner of a box, 0, 0 and 6 pixel. So the legend will be mostly in the center of the box. And the padding, we are not even creating any padding for the legend title. So here we are using a loop to taking the value from 0 to 4. I greater than the class names what we mentioned over here, the class names from the water till urban. Getting? Are you able to follow? So the for giving that color, so the legend will be in the color box. So red color box should have to be urban like that. To calling that color box, you add out label like creating the style for to get the color box also. Background color will be the class palette. What we mentioned over here, blue, green, yellow, and red color. It will be available in the same color with the same name. The same step to keeping the style of the color box also and the label also, and the legend row, like how it should have to be visible. It's in the horizontal manner or like in a vertical manner. That's we can mention over here to change that horizontal. UI panel dot layout flow. How that this legend value should have to come. It's in the raw format or like in a column that you can customize over here. To calling legend dot add legend row to add the legend row, and this map dot add layer, instead of it's not a layer, so that's why we are not even adding any add layer option. So that's why map dot add legend. So till here, if you type, try to run the code. So it came here with the title, class palette, class names and all. So this is how you can create the legend for your further purpose or like any needed. You can do the thing. Clear?
मजा लेता मैं मेरे दूसरा पकड़ा साहब में कर दिया आई को मिस नहीं करना is working. Is it working? Still working. When I grab this how do you grab? I have to keep this organization file. I have to keep this data to organization file. Am I right?
Final step. Till now we visualized everything. If you want the data, how to export the data from Google Earth Engine to your purpose. So for that I will explain how to export one data. Same method, same step only we are dealing for to export all the other layers. Here we are having different layers. So if you are running, it will take time to save it to drive. So what actually you are exporting from from the Google Earth Engine, it will directly store in your Google Drive what you mentioned over here. So this is the function to export the data from Google Earth Engine. Export as like image to drive. Which image you want? You are defining your images like S1 pre-flood, whatever you are required, S1 post-flood or like flood extend or the LLC pre like that. And the description of the image what you are saving inside the Google Earth Drive will reflect this name. Ernakulam pre-flood Sentinel 1 VV band 2023 somewhere like it's mistake. So the scale of the band, like you can keep the scale from 10 to 13 up to your what data, how much accurate data you want. And the region, we are just defining again the region till what boundary it needs to take while exporting. We are mentioning Ernakulam and the file format GeoTIFF. So here, like we classified the raster over here. That's why here we mentioned about the maximum pixel as like 1:13. So up to your system's condition or like again up to the accuracy, you can change the maximum pixel level like that. This is the standard to keep the processing faster, rendering fast. It is keeping us like 1:13 is the maximum pixel range. That's it. Anyone have any doubt in this today's section? So complete it and you will have a tea break. So if you run, you can see over here under task how much time it is taking to
तो 9 already आया. Next से क्या चेक करना. अरे रोड टाइम
खत्म हो गया ना अब दूसरा क्या है खत्म हो गया
It's loading. You can see over the task. It will show how much time it will take to export into Google Drive and all. After that, you can see one pop-up like run. Click the run. It will directly save it to Google Drive. Slow. So like this you can see, click run to save it into Google Drive. That's it. Thank you.
चलो.
He is waiting outside. Won't have. everyone settle down. Like actually in the day 3 tutorial, we missed some steps because like we are going to struggle while exporting the data. So we found out one mistake where we didn't do the thing. One was the drive only. You should have to keep your snap and the data about everything in C drive because like snap is running behind in C drive. So that's why like some accessory files or something it may miss, it won't run properly. And we found out one problem is it like after doing all the sigma VB band and all things, we are doing that band math. So here, so it's mentioned over here, save expression only, it is not even storing in our folder. So somehow we forget to uncheck this thing. That is the problem. If you uncheck the thing, it will automatically get exported into your folder. This virtual tick. So I think like we are having nearly 1 hour is left. 1 hour is left. We'll see the part that we didn't do that last day. We want to perform this in QGIS. That same thing what we did now in Google Earth Engine. We are going to see how to prepare that flood extent mapping in QGIS. And if time permits, we'll see how to create that proper map layout and all. Here maybe most of them know about the map preparation and all, but somehow some people may not, so we'll see the thing. So if you can export the data, please try to export the data. So after exporting, you can see inside the folder which one you are accessing. Inside that folder, you can see the last name what you exported. Maybe in postflood, VB, sigma, like that. So it will be in .img format. It's also on raster format. Still, if you are facing any problem, I just shared one drive link now in the group. Try to download that data. It is like a clipped one. It's in TIFF format. But try to export. If it is not getting, just do that. Any problem, please raise the hand because like we are running out of the time. We'll see the thing. If you are getting that access, please try to download the data if you are not getting while exporting.
So what we are doing here?
Pardon?
I do not understand. What we are doing here? I did everything in Google Earth engine. After that, what we are doing here?
This is not the continuation of the current today's section. This was the we missed on day 3 tutorial. Same thing we are just following.
So this is the first of day 3.
This what we are going to demonstrate now is not a continuation from the today's section. It's just what we left over day 3. That is what we are continuing now. So, will we start? So, okay, I think everyone downloaded the data or like exported. Anyone having any problem? Alright, like after that, just open the QGIS. You can add the raster layer like we mentioned earlier from the layer. Add layer, add raster layer like this. So where you export that, from there you can select the raster data. It's like it will show you a file directory where you saved your data. So try to select that IMG what you exported last, or like if you downloaded, maybe it may in the format TIFF format. If you downloaded data what I provided, you make it like this, pre-flood and post-flood data. Getting? Like maybe if you exported from the snap, you may get a one rectangular data. So you can clip the data with your steady area, what we mentioned, like it's a shapefile, problem shapefile. You can clip using raster clip from the QGIS processing toolbox. Toolbox mostly will be in processing toolbox, or either if you are using any older version, you may get from layer or like under raster. So here it is like processing toolbox. So here you search clip. You can see two clip. One is vector clip and one is like raster clip. You can select this option, click raster by mask layer. So here you can give your input layer what you exported from snap, and with which layer you wanna mask this layer. It is like your shape file. You don't need to give any source coordinate reference system, but should have to care about your target coordinate system. This shapefile and your raster data both should have to be in same coordinate reference system projections. So you can see over here like UTM in which zone your steady area is coming, or like your raster data what you exported. Try to select that, and after that to remove that no data value. Maybe if you are exporting or like clipping, you may get the black color raster behind your raster value. So to cancel out or like to remove the value, just keep it as like -999 and run it. So that's it. You can keep if you want to keep it as like a permanent layer, you can give any file output location, or you can run it as like a temporary layer also. So after that you will get one clipped pre-flood data and one clipped post-flood data. Getting able to follow? Oh. I hope everyone did like this. So after that, like how we find out the difference and the backscatter greater than 1.5. Same thing we are going to do in QGIS. There is one tool like that raster calculator. Here you can process whatever your data like value range of your raster. You can classify, you can do any analysis, everything using raster calculator. So anyone having any problem? So the next step, go to raster. You can find out one option like this raster calculator. Select the raster calculator. First step is to finding out the difference between the pre-flood and post-flood data. So just click once in a pre-flood data. Sorry, double click and minus and the post-flood. So that's it. Just to save. Give your output location where you wanna save. That's why we are giving greater than number. Less than. Pre-flood minus post-flood. So select the output location where you want to save the raster and click OK and run. I already ran, that's why I am not running this. So if you missed any syntax, it will show it is not valid like that. It is OK, that OK button will pop up. So you can run like that. After that you will get one difference TIFF file like this. It's not mean anything, like just classify the values. It have also some value range in between -30 to 33 to 30 like this. Done? Done? I hope like till here everyone got right. So after finding the difference, same step, raster calculator. Go there. Here you can find out your difference band over here. And what we applied over there for to find out our flood extent, we use greater than 1.5. Same over here, greater than or equal to 1.5 we are typing to give your output location, then click OK. So after that you will get one raster data with the value range from 0 to 1. It will be in this format. In this format, the symbology ranges from 0 to 1 like this. Getting? Any problem, please raise your hand. raster calculator. Raster calculator, right? Click OK. Select your difference band. In which name you saved it, it will come like this. Double click over the difference. In the operator, you can see the operating icons and all, like this, greater than or equal to, less than or equal to, like this. So here for finding out difference, we keep like pre-flood minus post-flood. If it is reverse, you can keep it as like less than 1.5. So like this you can type in the expression box. After that, output location, click OK to run. So you may get like this, right? Everyone got like this. Can I go forward? Done. So this will be like this in a single gray band. The value range from 0 to 1. 1 will be the flood extent and 0 will be the like removed values. So how you can change the symbology? Right click over this file layer, go to properties. There you can see source, information, symbology and everything over here. Select symbology. There in render type you can see multi-band, paletted unique values, single band gray, single band pseudo color and everything. You will choose single band pseudo color. Not single band pseudo color, paletted or unique values, because like we are having that particular unique values, it's not in the range. So select that paletted unique values. So here you will get some random color. You can change this color by double clicking this color panel. Whatever, keep it in any color because we are gonna make it as a transparent 0. How to transfer? Like you can see over here opacity. Just make it as 0 or like keep it in a left side. So it will come as like a transparent. Now over 1, you can give any blue color for visualization. It will be like this. Getting? Everyone? So after that, click apply. Click OK. You can find out the flooded area, flood extent. With this pre-flood, you can compare how much is extended from the existing pre-flood data like this. This is what we actually did in Google Earth Engine today. That's it. In the tutorial it's mentioned land use and same what we did in the Google Earth Engine classification also mentioned, and the further add-on part I added how to prepare map layout and all. If you wanna refer, you can refer, and if any doubt or mistake you are doing, just let me know. I'll just sort out that. So that's it. Thank you.
I hope you all had a good time doing this Google Earth Engine land use land cover change exercise in GEE. Hopefully you can save your work, save the code if you want, just for your practice, or you can refer to the manual later on. But the idea here is, of course, to shift from this topic to the next topic. There will be a full-blown SWOT demo and hands-on session tomorrow, but we have to do certain things before we do that. So both Ishwar and Rafi would be helping you to give you directions on how to install certain softwares. Three of them that you would install: QGIS, SWOT, and then SWOT Cup. But it will take some time. Hopefully some of you will be able to install, some of you may not be, depending on the permission rights they have on your machine. We had some issues with my own laptop installation, but we will try tomorrow. But it may take some time for installing the software, so that's why we want to use this last 30 minutes to install. With that, I'm going to give it to Ishwar. Three versions, right?
Did anyone have already installed QGIS? QGIS is already there, huh? QGIS, ArcGIS is already there. QGIS is there.
What is the version of that QGIS?
3.40. 3.44. 44 లేదు.
3.34.
No, actually, we need a 3.16 version actually. So
We can download from the repository. Yeah. 3.16 was somewhat long-term release one. So long-term. Yeah, but yeah, 3.34 is also long-term. But when we are running that, we used to get some Python errors. So 3.16 was suitable version. Don't get any errors. You just install it one more time.
Okay, sir.
Okay?
Sir, this one I will install and uninstall is which version? 3.16.
The problem is when we are doing tomorrow again, if we are using some other version, if we are using some other version, if we may get any error, we are unable to solve it. Yeah, we can install it. Yeah, you don't need to uninstall. Just install it one more, that's it.
Tomorrow was the feature, but if you can do that, it will be worthwhile effort for you.
So for the advanced versions, we have some problems like Python error and all. So we can depend on 3.16 version of QGIS. So we can download 3.16 only.
Yeah. Go to like you just see here. They are just showing one more time like how to download QGIS 3.16. Just type in the Google QGIS download. Let's go slowly. Yeah. All of you search this website QGIS download. Now click on that. Yeah, skip and go to download.
Skip it.
Yes.
Then click on archives.
RK folder file.
Yeah, click on that.
QGIS.work organization or head on
Yeah, go. ऊपर ऊपर
Windows. Go to Windows. Windows. Here click on Windows. Click on Windows. Here you choose QGIS 3.16. Yeah, 3.1. That's it. 3.16.
It's with 64-bit, not just 86.
.exe file. .exe file. Just double click it.
Which is having the size of 396 MB. There now.
396 MB. Download it. Just click on download.
Sir, 1.6. Sir, 3.16. Then next step.
No, 64-bit.
This one.
I think all of you already know, right, how to install it
Yes, sir.
after downloading. Okay,
Here
keep
is
it.
showing 14 minutes left. 36 minutes left.
It depends on that. So keep it download. Next one is QSWAT. Okay. For that, see here. Click on swat.tamu.tamu.
Edu.
tamu.edu. That is Texas A&M, the developer is. Swat was developed by Texas A&M. swat.tamu.edu. That's 396 MB. 396 MB. Here click on SWAT executables. SWAT executables. Come down. Here QSWAT. Just click on this. Download that QSWAT. SWAT executables. QSWAT. Download this. Yeah, .exe file. Yeah, .exe file. This is not open source. First download QGIS. See, when you are after installing QGIS, then only you try to install QSWAT. Okay, don't do this first and don't do that next. Again, error will come. Okay, first install QGIS, open it, just check it is opening or not, then install QSWAT. Okay,
Basically, QSWAT is a plugin.
yeah, it's a plugin in QGIS.
Okay, sir.
And after that,
Sir,
just keep it download mode.
Sir, I connect my laptop through LAN. Otherwise, after that, that is showing 2 hours, 1 hour. I know, but my laptop is connected to LAN local area. It should be.
.exe. After clicking here, it will directly it will go to here. You here click on .exe file. Okay, click on that .exe file.
After this, one more is there. Again come back to this swat commu.edu. Here swat editor. Click on swat editor. Again click on download swat editor. It will automatically download. Just click on that. It will be in downloads. Okay. First install QGIS, then install QSWAT, then install QSWAT editor. One by one. It will take, I think it won't complete now, it will take 1 hour. So, after reaching your room, you try this. Okay. Their net is not coming, huh?
Sir, you have no, I think you have some in your laptop. So will you provide us through pen drive? It will be better, sir.
Install in C drive. When you are running SWAT model, you must have some space in C drive. Okay, otherwise the model will throw error. C should be having at least 50-100 GB space.
In C drive?
Anyway, we are running for just 2-3 years, it won't take, but keep it 50 GB free.
For which drive? C or D?
C drive. The thing is, if the C is having more space, then it will run speed. Otherwise, while loading the raster files, it will take more time. Okay, SWAT is not like XMS. XMS is open, like that is very simple. Here, all the steps are linked with Python, so it will throw easily errors. At least maintain 50 GB in C. Try to maintain it. We'll see. Try to maintain it. And I think all of you are having 2 folders, right? C and D. Yeah. When you are doing that time you will do it in D. All installation files should be in D. Not here. Go to Windows. Right? No, both are not same. Both are not same. No, that exe file is not there. Go to Windows. Here 3.16.1. Go down. And while coming tomorrow, open QGIS. You know how to add plugins, right? QGIS. Try to open, add QSWAT, and let's just check it is there or not. Because it will take more time. So all these steps you do it in the room itself. Okay. Next software, SWAT Cup. Go back. Here, click on SWAT Cup. Click on SWAT Cup. Download SWAT Cup. Click on SWAT Cup. Download SWAT Cup. Come down.
My laptop is connected. Okay. It should be easy. The speed of
Understood?
internet.
QGIS, QSWAT, QSWAT editor, SWAT Cup.
So sir, do you provide me at beginning?
The data which is required for tomorrow class will send in the morning.
Okay.
Dialing will upload. Tomorrow morning we will class session.
Because it's one hour.
Here, once you click here, download startup, it will ask you to register. Just enter email, create the password. Just enter your full name. Just click on register. And install it. After downloading, install it.
They are getting straight through that. You are downloading platform. Right now. Within 1 week. 5 minutes, 10 minutes. Sir, can I connect with another line?
अरे वही तो इतने सारे लोग एक ही जगह पे पकड़ के
ना प्रोसेसर होगा प्रोसेस
मेरे स्क्रीन ड्राइव को